Hello and welcome to iOS 11 mobile app development and certification. My name is Vivian Arana and I've been doing more of iOS since it started, since iOS initially came up with App Store and they came up with their SDK. So I've been working on mobile apps since then. I have made more than 150 apps which are on App Store and some of them are still under work. I've worked on some of the very popular apps like cars.com, Washington Post, and bunch of other apps. And if you want to look more about me, you can visit my website vivianarana.com. Also about iOS 11, it's the most latest iOS available right now. It's always good to support iOS 11, 10 and 9. I'm going to show some of those things, how to pick that in Xcode. But iOS 11 came out in 2017 and it's one of the most recent operating system for iOS devices. Also, Swift is the new programming language, but I can't say it's new because it's been there for almost 4 years, and that's the number 4 at the end of it. Every year they come out with a new release. It's open source, and we'll be going over some Swift programming, how to learn it from basic, from very low level, how to make constants, how to make variables to functions to generics. And with iOS, we'll be doing a lot of different apps, from basic apps to some more advanced features app, which will help you submit your applications to App Store. So that's what we will be covering. Stay tuned. Prerequisites. So what is required to take this particular course? You don't need any development experience because I will be going over how to download things like Xcode, and also then going over basics of Swift programming, how to do Swift programming, what it means. And I will be following some of the very basic techniques like how to open Xcode and build your simple project without knowing anything. So you'll be learning how to make apps before you even know how to learn programming. Then we'll go into programming, learn Swift, and then we'll go over some of the more advanced features and techniques of that. You need a Mac OS, something running Mac OS system. It can be a MacBook, can be an iMac, anything that runs Mac OS. I don't like hacks where we kind of go into Windows and try to install Hackintosh or something else. It's always better to have a Mac OS system. You need to know how to use basic computer use, for example, how to use Mac, how to get around. You need to know how to use a smartphone. Of course, you're making smartphone apps, so you need to learn that. You also need some basic cooking. Just kidding. I give a lot of examples based on cooking, so that's why I wrote that. You don't need a device because we'll be using simulator, and also in one section I'm going to show you how the simulator looks like and what all functionality you use. But before submitting the app to the App Store, it's always good to have a smartphone and a device where you can test all these things that you're doing. Tutorial project files. So whatever projects that we go through in this particular tutorial, you can find them on GitHub. So I posted everything on GitHub. Also, it's in part of the tutorial series, but if you want to look for, you'll find it under my Git repository. You can go and search for my name and you will find my name inside that. You'll see a bunch of different repositories. The one that you're looking for is iOS 11 mobile development and certification. So you see all the different projects that we have worked on available right here. For any kind of development, the first thing that you need is an IDE, or integrated development environment. Now you've seen some simple text editors or Notepad or things similar to that where you can write some text and have your work done. But for iOS development, what you need is Xcode. Xcode gives you all these features available for you, which actually Apple learned over the last few years, initially by creating a simple version of Xcode where it gives you all the libraries and everything that you need at one place, and slowly evolving over last 10 years to give the best experience for the developer to build the best applications. So what it does is it's more like a kitchen where I have all my tools, and more I learn, I kind of buy more tools to make my cooking much more easier. So that's what Xcode is for me in the coding world. So let's go and download Xcode. So what you have to do is first go to open App Store. App Store is like an app store for your computer. Before, on your mobile phones, you have either Google Play Store if you're using Android, or App Store, Apple App Store on your iOS device. So this App Store is similar App Store for your computer, for your Mac. So what I'm going to do is, you can go to any application here. Similarly, you can buy them, you can download. If you're more into free apps, you can look up free apps, you can get paid apps. Xcode is a free app, so it will look something similar to this. So you can just press get and download. So let's search for Xcode. When I search for Xcode, the first thing that opens up is Apple's Xcode. So just to confirm, you can open it and look at it. It looks like this. The current version of at the time of this recording is 9.3, and it's updated on March 29th, 2018. So I have this Xcode available here. I can download it. Actually, I've already downloaded it, so it doesn't say get. For you itself will say get, and when you click on it, it might ask you your Apple ID if you're not already logged in. And once you download it, it will be available for you to use. So that's how you can get hold of Xcode. You can look at some information about Xcode, what all different features that they've added, what all different things are there, and also look at some of the screenshots available here and see what all it can do. So it's just like another application that you're downloading, just that this will help you to kind of code iOS applications and build iOS applications. So go ahead and download it. It might take a little bit time because it's almost 4 GB or 5 GB right now. So it might take some time. So keep it on download. So my suggestion is keep it on download at night. So morning when you're available, you have Xcode downloaded. So let's go ahead and next chapter, let's see how Xcode works. I hope you got your Xcode downloaded. And now let's start exploring Xcode using a new project. Now you can't learn something just by looking at the IDE or looking at the code. What I experience is when you start your projects, that's how you learn how to code. So that's what we will do. We will understand how Xcode works based on a project, and we'll go through the steps, and in the next section we'll see how Xcode actually is structured and how we can learn more about Xcode. So let's go ahead and start with a new project. So once you open Xcode, so let's say if you've downloaded Xcode, you'll probably see it in your downloads or in your utility area, and then you can kind of click on this and it will bring up this particular screen. There's no recent projects that you've worked on. It will give you the version number. During the time of this recording, I was using version 9.3. You can say it has 3 options for me here. It says get started with the playground, explore new ideas quickly and easily, create a new Xcode project, and clone an existing project. So you can start with the playground. What it does is it gives you a code editor directly where you can write some code and see the output as and when you do it. So I can give you an example of this. I can just create a blank application. So this is my blank application. And in here, if you see, I have something called as import UI kit. Now this is Swift, and I don't want you to kind of look at Swift the way people look at it and then kind of run away from programming. So just do whatever I do, follow some of the things that I do in the first 2 sections, and then we will look at Swift properly. The reason I say this is because usually when you look at a programming language, and if you're new to it, you get scared when you look at the syntax. So it's always better to kind of look at it, how to use it, and then implement it. I always say that if you're trying to learn a new language, you just learn the words first and then you try to understand what it means. So that's what I'm going to do in this particular tutorial. So if you see here, it says hello world. The string is assigned to hello playground, and it's sets up there. You can do a bunch of different things. I can say variable a equal to 10, and it will give me the value of that item right here next to it. So playground is somewhere where you can actually see things as and when you do items. So I'm going to close this playground, go back to Xcode. It will show my playground in the recent item since I just built this. So, and I kept it inside my projects folder. So I can create a playground. In this particular session, what we'll do is we'll mostly look at Xcode project, and this entire tutorial I'll focus mostly on complete projects and not just playgrounds. And the last option is clone an existing project. So if you have a repository, or if you have understanding of repository, you can get a project from somewhere like GitHub, or if your company has a repository, you can get it from there and open that project. So we're going to mostly work with this, create a new Xcode project. Another one more thing is every time you open Xcode, you'll probably see this thing pop up. If you don't want this to be displayed, you can always check this, and it says show this window when Xcode launches. And if I uncheck this, it will not show up again. So I'm going to do that. I'm going to open my Xcode. Now here, to create a new project, what Xcode gives you is a bunch of different templates and by different devices. So you can build iOS projects, watchOS, tvOS, macOS, cross-platform. We're going to look at some of these other different options, but now eventually we'll look at all the projects, but in the start we'll just focus on iOS applications, and I'll show how these are very much similar to iOS as and when we go in future. So these will be kind of discussed in a future section, but for now let's look at iOS application. So the templates that I have here is a single view application, which means it will give me an application with a single page, which is a white blank screen. Next one is a game template, which will kind of give me a basic starting of a game. Augmented reality, which actually gives me a plain in augmented reality you have a full-fledged app ready as soon as you download this, and we're going to look at augmented reality in one of the future sections. Document based app, this is based on documents that you can use in your iOS. Master detail app, this will kind of have a table on the left, a more detailed version. Page based application, where it gives you 3 different views similar to this, but you can actually scroll through them one page at a time, more like a carousel. Then we have tabbed apps, which gives me a tab at the bottom. You have a sticker pack app, where you can use stickers for messages, for different things. You can make your own stickers. And then we have iMessage app, which we'll also look in future section, which kind of lets you integrate things into iMessage. Then we have frameworks and library. We will be creating our own library in future, so this is what we will be using. There's CocoaTouch framework, CocoaTouch static library, and we have a metal library. So these are different things that you can use, kind of a framework or library, and share it with other people, or something that you think is common in throughout your project. You can build that and then use it accordingly. So we'll start with single view application as a first project. We click next. Next, it will ask me for the project name. So you can always change all these parameters later, but for now I'm going to say hello Xcode. That's the name of my project. Next is team. So we'll look at this team structure when we build it, because if you have Apple developer account, you can use your Apple developer account. Mine is already linked here, but I'm not going to use anything right now, because in future I'm going to show you how to link your own Apple developer account to your Xcode. Next, organization name. I'm going to use my name over here. You can, if you work for a company, you can give your company's name. If the project is for a company, if it's for your own sake, you can use your own name, and it depends whatever you want. And as I said, you can change this anytime you want. Organization identifier. This is usually the reverse domain name. Since I own vivinarana.com, I'm going to use it com.vivinarana. If you work for a company, say if you work for Delta Airlines, you can just say com.delta, something like that. So bundle identifier, I'm going to use com.vivinarana. And it will use this from the top. Again, this can be changed to. One thing about bundle identifier is it should be very unique. This is more like a social security number or your identity for this particular, for Xcode. So you have to make sure that this has to be very unique. If there is another app using the same bundle identifier, Apple will not approve, or even you can't even upload your application to App Store. So that's why they ask you to enter reverse domain name, because you're the only one to have that domain name, and then it takes the name of the project. So I'm not, let's say if I want to do it for Apple, I'm not going to use com.apple, because that's Apple's organization name, and there might be an application that Apple has built which has this similar name. So I'm going to give it my reverse domain name. Again, fix that. Again, language, which language do you want? So we had Objective-C, which was very popular in the start. When iOS initially came out, we would make applications in Objective-C. Now Objective-C is moving away slowly, because Swift is much more faster, much more better programming language, easy to learn, and it's much simpler to use. So in last few years, so the current version of Swift is Swift 4, and in last 4 years it's been evolving quite a lot. So if you worked with Swift 1, it was totally different than 2, then again major changes in 3 and a lot of changes in 4, and the current version is Swift 4. The reason it's kind of evolving so much is because it's a new language, and it's kind of improved upon by Apple every year, and now it's become open source, so it's much more changes come to it every year. So the current version is Swift 4. Use that. I'm going to keep these unchecked: core data, unit test, UI test. We'll look at them in future sections, but if you check them, you'll have extra code available on your application, on your first project, and we don't want that. So I'm going to click next. Save your project. So I'm going to say my desktop. I'm going to just save it on desktop for now, And next option is source control. Do you want to create a Git repository? So I can check this. This will kind of make a repository. If you are not familiar with source control, don't worry about it. We're not going to talk about the source control in this particular video or in this entire tutorial series. So I'm going to just keep it unchecked. This will kind of make sure that it tracks your files, as in when you change the files, it will keep track of all these files and make sure that you can go back to a particular version if in future you do something, if you delete some files. So that's what this is helpful for. So I'm going to say go ahead and create this project. It's going to set up my project. If you see on my desktop, it created that hello Xcode project. And if I want to, let's say if I close Xcode, and if I want to open that project, I can always go inside hello Xcode, and inside this I have this Xcode proj file. If I click on that, that's how my Xcode opens up. So that's your first project. Now I'm not going to go into much detail of this because I have my next video ready for that. But here is all the files. I'm going to just go over the basics. The navigation side has all my project files in there. This is the main editor area and this is the utility area. So what we can do is, just to get a hang of it, you can go ahead and press this play button. But again, look here, it says which is the project that I want and which device do I want to run it. So you get all these devices to run your application. It by default selects 8 plus. I'm going to use iPhone X and I'm going to click play. So what it does is it takes this entire code that is automatically generated for you using a template and compile that code, meaning it will take that code and make an executable, or in Macs is DMG file, like how you have exe for Windows, you have DMG for, and it makes an app file, which is, you can see in the products, there's app file, takes that app file, takes your Xcode emulator, installs in this particular emulator and runs the application. So that's the entire flow that it goes through when you press this play button. If I press stop, it will stop the application, and if you see, that application is actually available right here. I can, even if I'm not using the Xcode, I can go here and click on this application and it will open up for me. So that's how Xcode works. I can always go and swipe up here and close the application on Xcode 10. If you're not familiar with that, you can always change your device to one of the older ones, or maybe iPhone 8 plus. I can't say it's old because both of them were released at the same time. And if you see now, this 8 plus is opening up, and once it opens up, you'll see this application again being installed, and then it will launch for you. And it's nothing but a white screen. So that's a little bit idea of how to create your projects. And the shortcut for this is, if you go here and say new project, or command shift and N. So that's the thing. So if I press command shift and N on my Xcode, it will open a new project and you can start from that. So that's more about creating a new project. I hope you created your own project. So next we'll look more in detail of Xcode and see what all different things are available for us. Xcode structure. Now that you understand how a project is built or how a project is created, and also you have Xcode, now let's look in more depth of how Xcode will help you to do all the things that you need to do in iOS programming. So what we have till now is our project hello Xcode, and we ran it on the simulator. Now what I'm going to do is I'm going to close the simulator for now, and we're going to get back to this later. Kind of increase the size of my Xcode, stop it here. Since I just closed the Xcode, it just crashed the application, which is, since it was trying to debug it and trying to figure out what's happening, the link was broken, and that's why you saw that error. But let's go ahead and look at the toolbar. So this top section is the toolbar where you can cross, where you can minimize or enlarge, or you can maximize. You can press the play button, stop button. Play is for running the application. Which project, you might have multiple targets, which we'll see later, and which device you want to run it on. If you connect your own device, I'm going to show you how to connect your personal device or your company device and then run your application on that later. But for now, this is the main thing that actually runs the application. You can always kind of run Command R, or you can see the shortcuts here, Command R, which will run the application, which does the same thing as pressing this play button. So it's always good to kind of go ahead and see all the different shortcuts that are available for Xcode, which kind of will help you slowly of how to use it. There's also a lot of documentation, a lot of support for that. So let's go back to the toolbar. So this is more like a status item here, which will kind of tell you what's happening, what are you doing, is the application building, is it running, is it installing. So this is something that will show you the status constantly. Again, we have another bar, another section here, which kind of lets me select how my editor style is, or show and hide what I want to display, what I don't want to display as a programmer sometimes. So as I mentioned before, this is the navigation side, this is the editor section, and this is the utility section. Now if you want to show and hide some stuff, like for example, I don't like to see too much noise when I'm just coding on a particular file, so I can just hide bunch of stuff. So if you see, if it's grayed out, it's hidden, you can display them again, utilities and navigation, and then there's the debug section. This will be displayed when you run your application, so I can still open it and see you can do your breakpoints and all those other things here, which we'll see in a future section, how to use debugging tools in Xcode. Let me close this right now. And your utility section, which has a bunch of different things about, if I click on a particular, let's say UI application delegate in this particular file, if I click on this, it will give me the documentation of this particular thing. If I click this one, I can always press command and click on it and go look at more options. Command and click on anything kind of gives me a bunch of different options to look at and do things with that particular class. What else do I have? So let me just go here. So this section is where I can see one single file, or I can see two different files which are of similar type. I can see, maybe if I'm building my interface, I can have both of them together, or I can see my source code file where I can see how it is now and how it was looking before. Since I have no previous revisions, it will not show me anything. So you can kind of, there's a date that comes up depending on which one you want. And this is not a source control file. If you saw when we created this project and we said next, and we didn't select this create git repository on my Mac, so it will not kind of put it under source control. But if you check that, it will show me what all changes have happened since I last opened it. So I'm going to close this, go back to my normal editor mode. So this is the standard editor, this is assistant editor, and version editor. So that's what it is. So assistant editor is mostly like, before when we had Objective-C, we had one file .h and .m here. Now you can actually select what you exactly want. You can kind of go ahead and select manually if you want any other file. Let's say I have view controller on app delegate on the left, I want view controller on the right, can have both those files open. Again, you can also open tabs by pressing Command T and have multiple files at the same time in different section. Here I can have view control open, here I can have app delegate open. So you can have multiple tabs again, just like your browsers these days. So close these tabs. Again, in the navigation, you have a lot of different options, and we will learn this as and when we code more and more things. There is your breakpoints, there are your warnings, errors. Whenever you run your application, you can search different things here. I can say app delegate, and it will show me where all app delegate occurs in my file. I can always filter things from the bottom. I can say app delegate, and it will filter to only that file, because eventually you'll have more than one single file here, and that's how it works. Again, one more thing is I can right click and say show in Finder. It will show me where my project is. It has a hello code folder here which maps to this, and inside this we have this. But where is the base L proj? I see assets over there, app delegate, view controller, info plist file, but where is this main storyboard? If you kind of go inside, you see main storyboard, and you'll see a launch screen. Inside assets, I can see this assets icon. So why is this different from this? So this is not an actual representation of this. The representation of these files is kind of controlled by this file, project file here. This is an XML file. If I say open as Xcode project, it will display here, but it's nothing. But if I would try to open this in any other editor, it will show me a bunch of XML which I'll not understand. So I can go in more like this format, and you'll see it more like a file where has bunch of different information about the project, but it doesn't make any sense. So to you because this is completely managed by Xcode. So that's what that file is, and don't try to go and modify that manually. Just use this editor here to kind of manage all the settings. So if you see, this project has a bunch of different settings here, and we'll go over a lot of these, especially with capabilities of using multiple things in our application and how to enable them, how to use them. We're going to see that, but don't play around with them right yet. We'll go one step at a time. So that's your complete Xcode structure. I hope that is helpful, and as and when we do more projects, we'll learn more about Xcode. Xcode interface. So we saw the entire Xcode structure. Now what is Xcode interface? Xcode interface for me is something where I can do coding just by drag and drop things. Now you'll see, if I see just code, where's the drag and drop thing? So if you see, we have a bunch of different files here. Now what I'm going to show you is, as soon as the application launches, what it does is it kind of picks up the interface, or it kind of picks up the application logic from here, app delegate, and then it goes somehow to view controller. But the display of it, you can design it using this main storyboard. There are two storyboards here. First storyboard is called as the launch storyboard, which is the screen that you see when the application launches. So if I run this application, there's a screen that shows up for a minute second or few seconds and then disappears, and that's this launch screen. And as soon as that goes away, it will launch the main screen. So you don't see any difference, because if you see the launch screen and the main screen, both look the same. So I'm going to go ahead and take my launch screen. I'm going to click on the view here. Don't worry about what all these means, because we are going to go in much detail in future sections. And I'm going to change this thing to, let's say, this. Oh, I've changed nothing, so I'm going to say I want this color. I'll leave it here, run the application, and you'll see it will display that thing for a few seconds, and it's gone away because it launches this particular screen. You can do the same thing for this. I'm going to make it more like a magenta color, run this application, and now you'll see the cyan color display for a few seconds, go away, and I have magenta. So this is how you can display your screen and build a lot of prototypes pretty quickly. You have a lot of different, this thing is the library in the utility section, where you can drag and drop items pretty quickly and have your application up and running in no time. So I can just do all these things, run the application, and have my application running here, and all these buttons work. Now this looks a little different from this, because if you open it here, you see it will say that the view that I'm displaying here is same as iPhone 8, but I'm running on 8 Plus, so I can change the screen design based on what I'm designing for and accordingly change it. But how do application developers do it? Do they do different designs for different layouts? Actually no. What they do is, we use something called as auto layouts, and using auto layouts we can make sure that one section is, or how it's set up, I can define equal widths, heights, all these different parameters that are available of how a particular thing will stretch or not stretch, and assign them a proper UI so it looks perfect in all the different screens. So that's something that we'll learn in one of the section, which is auto layout section. But for now, if you look at this, now this is how we can kind of create. And in the next section, we'll create a bunch of applications, 6 to 9 applications, which will have storyboards quite a lot and very less code, and you'll have completely functional applications. When I say completely functional, they're not ready for App Store, but you understand a lot of things from that. Very less coding, but a lot of implementation, which will make you kind of motivate you to write more applications and learn things quickly. So that's more about my interface here, and play around with it, look at the different options available, look at the properties on the side, and try to play around with these things and get yourself familiar with this particular thing, because in next section we'll be writing some applications. Xcode preferences. Now we know how to use Xcode, all the different parts of Xcode. Let's look at some of the very important preferences that would help you while you're coding. Everybody has their own preferences, so it's better to kind of pick yours. I kind of have a special preferences for this training, just because I like to see the font really big and make sure it's clear to the person who's actually looking at the code. So let's go back to Xcode, and you can find your preferences right here, or you can press Command comma to bring this up. There's a lot of different options. You can show live issues, continue building, automatically unlock files. So these are some of the basic things that you would want. Then there's account. You can set up your accounts. I can remove this and then show it later how to kind of set up your Apple ID and your developer account to this. Next thing is behaviors, how your Xcode works, what you want to see, what you want to do, when, what time. The most important one out of all of these are the fonts and colors. Again, in navigation, you have a bunch of different things for tabs and things that you would want to do when command click on code, what should happen, all those things, the things that we've seen before in the previous one of the video where I showed you when you command click on a particular piece, what should happen with that. Another thing is fonts and color. This is the most important one because here you can set what style you want. This is the default style that usually comes with it. If I set that, you'll probably see something like this when I run my code, but this is not clear for this particular purpose for video, so I'm going to select presentation and have my font a little bigger so you can clearly see what I'm doing. So here similarly you can pick whatever you like. A lot of programmers I know prefer midnight. If you don't like the different colors, you can use the printing one, maybe a sunset color, a little bit easier for the eyes. So you can pick based on what you want. I'm going to skip presentation for this one. Another important option is line numbers. A lot of times developers talk to each other and say, oh, check the line number 22, and then you want to kind of go to that line number. So you can display your line numbers or hide it however you like it, kind of. And a lot of different text editing settings available here. You have key binding, source control, how to set it up. You have your components, different simulators that are available for you. Where is the location to save things? You have your server and bots. If you want to set up your CI/CD server, this is where you can set up that. So that's some of the preferences that you have, and set your preferences based on how you like it. Even your shortcuts you can set there. So that's all about Xcode preferences. Do that before you start the next section. Hello iOS simulator. So we already saw a bunch of different simulators. We saw iPhone 8, we saw iPhone 8 Plus, and we saw iPhone 8X simulator, which comes as part of Xcode. Now let's look at some more things about simulators that we can do and we can play with. Like when you start an iOS development course, you would think that you might need a device, but device is not required in most of the cases, or in programming you don't need 95% of the times you can just work with the simulator. But it's always a good practice to kind of run your application on a real device so you see how it acts. So you can kind of get an opportunity before you publish your application to the App Store or before you show it to someone else, you know that everything is working fine. But just in case, if you don't have a device, it's okay, the sim works perfectly fine. And you know that you can kind of summon the simulator or whichever simulator you want just by clicking this play button, and your application launches inside the simulator. It kind of installs it and opens the application, and you have your application running. You can always change your simulator by going to the simulator option here. You can look at the simulator, some properties about it. You can look at different services. These are the basic ones, hide simulator. But in your hardware, you can select which OS you want and which simulator you want. We also have some Apple Watch simulators, tvOS simulators, iOS 11, iOS 8. So these are some of the things that I've installed and available. You can go to the components and install more simulators if you want from your Xcode preferences. You have what if you want to do some more activity? You have slow animations. If I set this and click on the application, you see how it opens up slowly. Can close it and it will close back slowly. Again, you can look at the file structure, and I'm not running this video in a slow-mo, just that I'm talking slowly as in when it happens. So when I switch something or kind of do anything that I want to do, it will act in a very slow manner because of the slow animations being enabled here. If I change this, it will go back to the normal mode. This it kind of helps you to see each and every frame on your device on how it will act. You can have your graphic quality, how you want it, color blenders, blended layers. You can kind of see all these different options available here. Location is one of the important one where we can see how it works. You can have your freeway drive, which actually simulates a location on Apple's, next to Apple's office. It will show you driving. So if you see now the location here, if I zoom in, it will show me that I'm actually driving because I've set the location to the drive mode. Let me zoom in. It's not that easy to actually move around because right now I'm using one finger. I can actually use two fingers by clicking Alt or Option and then kind of zoom in or zoom out. It will be based on, if you want to move the entire thing, the center is in the center of the device, but if you press Shift and move around, you can kind of take it wherever you want, and then leave Shift and zoom in based on that. So if you see right now, my current user or the current location is constantly moving because he is, you can always click this and then go directly to the user's location, and if you see, he's driving right now. I can change that to go in a mode of city run, bicycle ride, Apple Office, and when I do that, it will go to the Apple Office. The maps are quite a lot of things that we can cover in maps, but we'll look in the map section. So I'm going to close that for now and focus more on simulator because there's a lot of things I can do. You can restart your device, you can erase all contents and settings. What that will do is it will erase this hello Xcode, and kind of, if I do this, it's going to take some time and erase that entire device. And if you see, my application also stopped since it got disconnected from the simulator, and it will kind of do a factory reset on the device, on the emulator. So it will get back, it will delete all your application that you've done. You can have rotate left, rotate right, or command arrow is what you can use. You can set a particular orientation here to different, whichever you like. You can have a shake gesture. If you don't have a device, you can't actually shake your computer, so you can have shake gesture where it will kind of simulate a shake gesture. You can, instead of clicking the home button, you can use this lock button, will lock the device, and now if you see, it's locked. Since I've also factory reset the device, you see that application is missing that I had installed before. Also I have Siri option where it will enable Siri and do things kind of whatever I want here.
Is this thing on?
So if you see, that's what it says. So there are a lot of different options that you want to play around with it. The main one that you'll probably use is device. It is this thing, home, shake gesture. Depending on what you're doing, you can provide audio inputs, audio display. You can also have an external display, like you are kind of when you use Apple TV or Apple Play or mirror your device, you can do that with this. You have all these different options. I would say before you start writing applications, look at or explore all the different options that are available inside the simulator. And that's it for now for simulator. I hope you get a good hang of it, and if you have a device, I'll show in future section of how to use your device with Xcode to run your applications. MVC, or something that's called as model, view and controller. This is a very common design pattern that has been talked about or mentioned a lot of times, but how do we understand model, view, controller, and why are we doing this at the first place? So if you look at our project that we built, it has something called as view controller. What does this do? So let's kind of split this into three different sections, or let's bring up that diagram that you see quite a lot. So a controller is something that controls the flow between model and the view. But what are these things? So view is something that a user can see. It can be a screen, it can be a view, a button, it can be an element on the screen. So whatever the user can see is a view. When he interacts with it, when he clicks on a particular button, for example, there's a user action. He clicks on a button, the action goes to the controller. The controller, according to the action, whatever happens in there, the controller will have to take some step accordingly. So let's say the view says, can you download all the recipes from the internet? So it goes to controller. What controller does is it will download all the recipes, and once it does something, it processes it and it updates the view. Now how does model come into picture? So model is a representation of any object, or let's say model is a structure. So when I say, okay, I want to download all the recipes, controller goes and downloads the recipes and then gives it to the model, and model will notify the controller that this is what is available to you, and it will take that and update the view. To give a better explanation, let's look at this one. Controller is more like a chef, someone who controls the entire kitchen. all the model is nothing but ingredients, and view is nothing but cooking pan. So cooking pan is something that a user can see, or I can see when the chef is cooking, and I can say, hey, I don't want, or I want jalapenos. That's something that I'm asking. The chef, who's the controller, he's gonna go to the ingredients and say, can you give me one of the jalapenos? And it'll say, here you go, and it will update, or he's going to add it to the cooking pan. That's another example of it. But model view controller is something that we use constantly in our application that we built. If you see, this is our view. This is how it looks like. If I click on a particular button, it will go back to the controller, view controller. How does it know which view controller it is? If you look here, every single item here or a view controller has a name that I can look up here, and we are going to use this quite a lot in the next section. And it goes to this guy and it says, what do I need to do? Right now I've not written any code, and in the next section we'll see that. And based on what happens, the controller, whatever happens here, the controller will take action depending on that and do things to change items on the particular screen. And we will look at a lot of different actions. I just wanted to go over this particular design pattern because it's used quite a lot in different examples, and a lot of times it comes up. So just to give an example, that's how model view controller works. Section follow blindly. So the reason I call this section follow blindly is because in this particular section, since you already have Xcode and simulator and everything running up and you have your first project ready, what I want you to do is follow blindly whatever I ask you to do in this particular application. What I will do is I'll kind of make you work with much of different applications, 6 to 9 applications, and you will build these applications just by following some instructions. And once you're done with that, you'll kind of feel very motivated or kind of interested in building applications, and you don't have to understand anything that we write here in code, but just get an idea. So even if you pick up 10% of whatever we cover here, that will be good enough to understand more on programming or more on laying out designs in the future section. So these are very small, simple apps that we will build in next, let's say, couple of hours, and understand a lot about Xcode or how to walk around in a particular area. So the reason I said walk around, because you need to get familiar with your territory before actually coding something. This will kind of make you comfortable to do the next steps, which is learning programming or making applications. So this is the base for your applications, even though you will not understand much of it, but you'll kind of build some applications by following this section. So just follow along whatever I'm doing, just do step by step, and you'll build 6 to 9 applications by end of this section. First project. Now that we are familiar with Xcode, our environment, what we're going to use, iPhone simulator, so we know what tools we have, what tools we need, and everything is set up. Let's go and look into first proper project. This will be a very simple project which I have divided into different parts, and also we will be looking at a lot of different projects in this particular session. So the first part is what I want to cover is outlets. Outlets is something that you can actually see. It's a way for user to interact with the application or get some information from the application. It's something, as the name says, it's an outlet where you can display information to the user. They can look at it, they can do whatever they want to do with it. When it comes to doing or user interaction, it's more as belongs to part 2, which is actions. But in this part, we'll probably look at our outlets, and let's see how we can add outlets to our application. So let's start with a simple application. I have my simulator ready. I have my Xcode open. I'm going to create a new project, and I'm going to select single view application. I'm going to use my product name as first project, and there you go. Next, save it in the projects folder, and I have my application ready. I'm going to play in iPhone 8, so I'm going to select iPhone 8 here, and my first project, everything is all ready and set up. If I look at my storyboard, it has that same white view available. I can select on it. I can select on view controllers and the connections inspector, and I can see that there's something called as outlets here. How many outlets do I have? I have one outlet, which is this particular outlet, and that is already been connected with our code, which is in view controller. So this file actually represents our view controller.swift code, whereas this here, it says that this is the view that is being controlled by this view controller, and the view here is actually connected through a variable called as view. So if I want to access that view in my view controller, let's say in view did load, I can just say view dot, let's say background color. If I want to give a background color, I can just say, let's say UI color dot red. So I can give a color to that application by just saying that, to the view by just saying red, and I am taking the outlet and I'm giving a background color of red. So as soon as that view loads, you see it changed the color to red. Now I don't want to do that, so let's get rid of this. I want to add some more outlets. Now how do we add more outlets? I can go to the library at the bottom, and what I want to do in this application is a way for user to enter his name, and we want to display this out or just welcome him to the application. So I'm going to look for a label where I'm going to display his name. So initially I'm going to set it to just welcome and go to the properties and center align it, make it a little longer just in case if the user has a longer name. I'm going to go create a search for a text field, add the text field all the way to the top. Maybe I want to give some space, can go all the way up. I'm going to give a placeholder text, say enter your name. So I have that placeholder will display here. And next I want to add a button which when he clicks displays his name, takes the name from above here and displays it here. So I'm going to say go, something like that. So in this case, if I look at it, I already have one outlet which I defined to you is the view outlet. Other than that, I created 3 more outlets, 1, 2 and 3. Now when you are using an outlet, you're kind of defining an outlet in your code. That's how your code knows what to use when. Now in this case, this can be used as an outlet, this can be used as an outlet, the button can be used as an outlet, but button can also be used in action later. Now for this particular tutorial or for this project, I'm going to use all of them as outlets, and as and when we do more, you'll probably learn how to make sure that you know what to use as outlet and what not. So just for the start of the project, I'm going to hide both of them, go into my multiple view, and here I'm going to take my text field and I can just control click it. So control click it and then go here on the right, drag it on the right side, and I can leave it here, which we learned before. I can say I want to create an outlet. The name of this outlet is, let's say, name text field. Always remember to give proper names to your outlets or variables. For this button, I can create one. You can say outlet UI button. You have to make sure that you look at the type properly. I'm going to call it my go button, welcome label. So I'm going to call it welcome label. So now when you look at it, I have connected all these 3 items as outlets here at the red outlet. If there is no plus here, that means you're missing something, and so if this particular circle needs to be filled up. If it's not filled up, that means it's not connected. So I can go back here, I can show you something more. So if I go here, go to connections and go and break a particular connection, I can press this X and break this connection, and you'll see it's broken here. You can connect it again by taking it. If you see here, if you move with this on top of it, it will not connect because this is of the type text field and this is label, this is button, so it will not work. If I go here, it will work. It say, oh, I found a text field. Is this the text field that you're referring here? I say yes and connect it. So that's how you kind of create your outlets and kind of tell your code that where these outlets are. Now in future, you can use these outlets to kind of set some actions here. The controller can actually control, or in our example that I gave before, the chef can actually say what goes where. So that's how outlets are useful. Outlets are just a way for the chef to kind of tell the pan or the cooking area what needs to be done, because the cooking area itself is dumb. The chef is the controller, he's going to kind of tell what to do, and that's what outlets are. So our first project went along quite well and we learned something about outlets. So I got that's clear, but if it's not, we're going to do around 6 projects with the same things over and over again, just so that you understand more on that. And if you still have questions, you can always always feel free to post it at this particular course. So next one is actions. So actions are some interactions that user actually perform, like typing in a text field or maybe clicking on a button. So these are the things that we'll have to actually catch through functions. You don't have to understand completely about the programming side over here, but just the idea of how it actually works. So let's go ahead and take our project that we built. And here I can do some actions for a text field too. There's no actions on labels because user can't interact with the label. It's just a static item that you as a controller can control, but user just gets to see it and read it. So I'm going to take this function, delete this function. I don't need this. I'm not going to use that did receive memory warning function. I'm going to go to the button, do the same thing that I did with for outlets. I'm going to press Control and drag it right here and leave it. But instead of outlet, I'm going to select action. I'm going to leave everything as it is here, just that I'm going to change this as, say, button clicked. So what will happen is every time the user clicks on the button, this function will be called. And what do I want to do in this function? Let's make it a little bit more readable. Here, what do I want to do? What I want to do here is I want to make sure that the label that I have, which is my welcome label, has a property called as text. So that's how you get properties dot text equal to whatever they entered inside the name text field. So I'm going to say name text field dot text. So I'm going to take the value from name and display it in welcome for the first part. Let's see if it works. So when I run it, it's going to go to my simulator. I already have the copy before because I ran it when I created outlets. There you go. Also here you'll see that when you run it, you'll see a lot of debug items displayed in the debug area here. And if you don't want to see these unnecessary items, all you have to do is click on the first project, edit scheme, go to your run section, inside arguments. So if info is selected, just click on arguments here, this tab here, click on add OS activity mode and value disable. Close it, run the application, and you should not see any more of those debug logs. So that's just kind of whatever OS activity is going on, you're just disabling them. So let's see here if this worked. Go back to the app, enter your name, let's say no, click on go, and there you go, it shows my name displayed over here. I can make it more dynamic or make it more welcomey. Let's say I can say welcome, and using string interpolation, put this inside the bracket and assign that text to that. So now this one will show it says welcome optional Vivian Arana. The reason it's saying optional Vivian Arana is in Swift, what happens is if you look at this text variable, and that's what it's trying to help you here, it's saying do you want to make it something like this, but this is not what I want. So if you look at this property text, you see it has a question mark here, which means this value can be a value or an optional value. So what it does is it takes this value and puts it inside a box or something called an optional box, so it doesn't crash your application. What you can do is you can do something like that. If let's say my name equal to, so I'm doing a small check here, I'm putting this value inside this, and if this value exists, what I'm going to do is I'm going to say welcome text equal to welcome. I'm going to use this my name instead of this here, and now when I run this, it will check if this text value is nil. If it's nil, it's gonna get out of it and not do anything. But if it's a value, it will unbox that value from the optional what we saw before and display it properly with the And that's how actions work. And we're going to look at a bunch of different actions too in all the different projects that we're doing, but this is part of our first project, and there's one more, which is the cleanup part. So that's it for actions. First project. So till now what we got is outlets, how to set our outlets, how to set our actions, and the third part of this project is perfect the app or the user experience. So what we see right now is there's something imperfection in the app, and that's what we'll try to figure out. So we learned how to create, so this is the app that we built where we had a text field to enter your name. So I'm going to enter my name here, and when I press go, it's going to take an action from me and display my name here. So that's how this app works till now. Now the next thing that I want to do is something that we didn't realize is when I remove something here, if you see here the keyboard came up, right? If the keyboard doesn't show up, you can always go here and toggle software keyboard, which is Command K. So if I go here and press Command K, it will hide the keyboard or show the keyboard. But in a real device, in the simulator right now, I can just type on my keyboard of my laptop. But if I try to use the keyboard here and press, let's say my name is, it's a little difficult to type on this. I'm gonna just write my first name, it says, but the keyboard doesn't go away. I expect the keyboard to be gone once I press go. So if I want to get rid of the keyboard, what happens in this case is this text field is the first responder, or let's say in this particular case, when I run this app, the responder inside this application is the view right now, and view is listening for different events that are happening. As soon as I type on this, the text field becomes our first responder. So whatever I do on the keyboard or here, the keyboard is listening for events to happen. And what I have to do is, after I'm done my typing and press go, I need to resign it as being first responder. So by resigning it as first responder, it will take away control and the keyboard will disappear. So let me show you how to do that. So as soon as I'm done button clicked, I'm gonna say the text field that I have, name text field dot resign first responder. As soon as I do this, let's see what happens. So my application came up, enter my name, go, and there you go, it disappeared. Another way of doing it is, like, let's say if I have 3-4 different text fields. Now how do you know which one is selected, which text field is the user on? So what if I click somewhere else outside and the keyboard disappears? So in that case, what we'll need is something called as touch as began function. This is one of the built-in function which is on the view. So as soon as I can kind of say, whenever user clicks anywhere else other than the text field, I can say the view. Where did I get this view from? If you remember, in the outlets, when we saw in this first point, there is this view object, which is this entire thing. And I'm saying no matter where you click here, so view, what I want to do is I want to end editing, force it to true. So it's another way. I'm going to comment this out just to show you that this works. I click on my text field and the keyboard comes up. Comes up and I click somewhere else and it goes away. Click on this, press Viv, go, and it says welcome view. If I click somewhere else, and there you go, that's a perfect user interaction where user looks at the screen, looks at the particular text field, enters his name and presses go or press somewhere else, and the keyboard disappears. So this is another way of kind of making sure you follow some kind of, so if the user doesn't want to use the text field and just go away from it, you still can get rid of the keyboard, because there might be some text or some elements below the keyboard that you want user to see. So if he clicks here, just get rid of it. This is how you do it, and that's how we make our UI look much better for user experience, and they probably will have no complaints. Second project, or what I like to call it, let it slide. So now from our first project, we learned enough how to use some outlets, some actions. In this particular project, we're going to do something similar. We're going to start with some outlets, some one action. Now all these things will be on a particular slider. That's why I call it let it slide. So let's look at this project. Let's jump in straight away and then create our slider. So I've already created a project, call it slider project. I have my simulator running. I have my storyboard open here, and inside my main storyboard I don't have anything. I'm gonna go and search for a slider. I'm gonna add a slider here. Now once I have my slider, next thing that I want is label to display its value. Make it, go and play around with some properties like make it center aligned, make it a little bigger. I'm gonna go this, I'm gonna give it value, current value 0. The reason it's in the center is because the value goes from 0 to 1 and 0.5 was selected, and that's why it was in the center. I'm gonna go and change it from 0 to 100 and keep it in the center. And here I'm gonna say value equal to 0.00. That's what I'm gonna set for the initial project. Now let's go and create our outlets. So we see 2 outlets, so let's go and do that. I'm gonna go and make some room for myself here. Take my slider and just like previous class, drag and leave it outlet for UI slider. I'm gonna call it slider. I'm gonna take my label and I'm gonna call it display label. So I have both my outlets defined. Next, what I'm going to do is I'm going to create a function. So whenever this slider slides, I'm going to select this, add it here, and call this guy, not an outlet, action. I'm going to call it slide. So when it slides, it's going to call this function. You don't have to get into details of what all these different other things mean, like at the rate, why week, why variable, why var. What is this? Only thing you have to know right now is the names of these. In future we're going to go over each and every parameter, what they mean, why do you add those. So right now, just to get used to the environment and familiarize yourself and quickly build some apps so you can motivate yourself, we're going to do this. I'm going to go there here and I'm going to say the value that I want to display dot text equal to whatever the value that slider has. Now if you look at here, this text is of the type string, but the slider value is of the type float. So you're trying to assign a float value to a string, which will not work. So what I'm going to do is I'm going to let's go and make sure we have full space and our code open. I'm going to do it, I'm going to say that I want to create a string for a particular format, and my format will be I'll say percentage 0.2 f. So I'm saying that I want a float value to be used inside the string format, comma, close this bracket here. So what this does is it creates a string of this particular format, and what is the value? It takes the value from here. Now if I just leave it like this, let's see what happens. So the reason I'm saying 0.2 is that means two numbers after the decimal point. So what it will do is it will display it like this. Now if you see, there was value colon the value in the start when the application ran, and then it just shows that. If I say 3 here, now I'm going to see 3 decimal points. There you go, my 3, but I don't see the value anymore. So what I'm going to do is keep it consistent, say 2, and run this. So you can add any type of format you want here and display the value in here. It will take this and substitute the value from the float here. So there you go, now it looks more consistent. If you don't want like the way it moves left and right, you can actually left align it or right align it, or make it 2 different labels, however you want. So this is the second project where we see how we can use a slider and display the value based on the slider. Third project, on or off. In this case, we are going to use something called as a switch, and what the switch lets you do is it's more like a radio button. You can check it on or check off. So as the name says, switch, it has 2 different properties, either it's on or it's off. And What we'll do is, based on the color of the switch, we will change the background color of that particular view on which the switch is. So we're gonna start with the project. I already have a project available. I'm gonna go and look for a switch, and there you go. That's how switch looks like. I'm gonna move it to the center of the screen, and there are two different, as I said, the state is on or off. I'm gonna set it off and change the background color of this particular screen to, let's say, red. You have to make sure that you selected the view by doing this, and then change the color to whatever color you want. I can go here and I can select red color. Now I can do it using this color picker here, whatever color I want. Can go here and select bunch of different options that are available to me. I'm going to go here and I'm going to say, let's try to pick as close to that as possible. Oops. Or I can go here and I can use my RGB sliders and say red is 255 of red, 0 of green, and 0 of blue. There you go. So that will give me the red color. So that's how colors are defined. I mean, every color in numerical form goes from 0 to 255. If everything is 0, you get black. If everything is 255, you get white. So it goes from one spectrum to other spectrum. Since the view is selected, it might look a little bit different, but here is the selection color that you'll see. So I'm going to set everything to blue. Also, if you have a hex color, you can give that color here. The first two parameters is red, next to is green and blue, and it goes from 00 to FF. So that's how numbers work. So that's where colors work. Let's go and try to do some stuff. Now in this case, I only have one outlet. If you see, the reason I say only one outlet is because view is already connected, so I don't need to do that. Go here and split the screen. I'm going to take my button and I'm going to switch and say my switch. Now let's select this switch and create action for it. Action, and I'm going to call it switch changed. Here I close this thing. Let me open this back. Let's go single screen and go back. Now if you see, I created an action which will kind of be called when the switch changes. In a case of switch, you have two states. So I can always say if my switch, that's the name of the switch, dot on. So I'm checking Boolean value, is this switch on? If it's on, what do I want to do? Else, what else do I want to do? So since in this case, when it's on, I want to set the background color. I can say, I can use this class called as UI color and give its properties. Now the color that I want when the button is on is green. I'm going to say green. Else, when the button is off, I want red. So this is how you can set your switch colors. Let's go run this project. Put on simulator. It's going to install the application, and there you go. Off, on, off, on. This is how switch works, and it can be used for a lot of different purposes. For whenever you have Boolean values, whenever two set of values, you can use it for, let's say in a form, you can say you want to select male, female, so on and off. So depending on which side what you have, you can add two labels on the either side. So you can kind of go crazy with this particular button and then use it however you want. So that's how switch works. Fourth project, the segments of life. So this is another project that I came up with where we're going to introduce you to the segmented control. Again, we're going to do the same thing. We're going to have three segments of life in this segmented control. Let's say your childhood, your youth, and old age. Let's say that's how I divide it. And we're going to create outlets and actions just like previous projects and just get more familiar with this segmented control. So I already created a project, and I'm going to drop inside a segmented control. Segmented control looks more like tabs, and I have only two items in here. So let's say if I create first one, say childhood, youth, and I want to add one more. What you can do is you can select this, add the number of segments to 3, and then double click here, and you can say old age. 3 different parts of life. Next, I want to label. Again, move it all the way to the left. Time. I am going to say, since childhood is created, you can actually have them whatever you want to select it, or you can just have unselected, where you can say okay, you select whatever you want. So in the start I can just say select 1, something like that. So these are my 2 outlets that I've created. Let's connect them with our view controller. Go back here, get rid of some of the things, and here select my segmented control, and I'm going to call it segments of life, and for the label, display selection label. Make sure it changes the display when this thing calls. So I'm going to create an action out of this segmented control and call it segments of life changes, and I have my function ready. Let's expand the space to just have our view controller. In here, what I'm going to do is, based on what is selected inside the segments of life segmented control, I will change the display inside the display selection label. So how do I do that? In this case, we have 3 different statements. I can say if else, and else, or I can use switch. So I'm going to use switch statements. Switch is much more convenient. Now in here, switch works based on what is selected. So I can give it 3 cases, can also give a default, but I'll give it 3 cases that I have. So first I'm going to say switch based on segmented of life selected segment index. Inside my segmented control, the first one has a selected index of 0. This is the 1 and this is 2. So here I'm going to say if you select 0, I'm going to say that display selection label dot text equal to you are still a kid. I'm going to copy this 2 times, case 1 and case 2. So if childhood is selected, it's going to say you're still a kid. If youth is selected, time to grow up, that's what I'm going to say. And when the third one, old age, is selected, let's say retirement time. That's it. That's what. And then I have option of default, which will never hit because I have only 3 cases, but still I can say not sure what happened, thing like that. So I have these switch statements with different cases ready. Let's run it and see how it looks like. I'm going to run it again on our iPhone 8. And here we go, all 3 segments, nothing is selected, so it says select 1. You can say okay, you're still a kid, time to grow up, retirement time. So you can keep on switching them. So this is how you can actually display like 3 different pages and have 3 different views here doing different things. So that's what segmented controller is mostly used for, and it's pretty helpful when you want to display multiple options, or even you want to give options to user to select multiple options than the switch that we just did in the previous chapter. So this kind of gives you multiple options. 5th project, a picture is worth 1,000 words. So we played enough with all the different controls that are available. Let's look at how to add some images into our project. So I'm going to start with the project. In this case, we'll probably look at all the images for outlets, and for actions we'll use a couple of buttons. So let's look at this project. I've created a project already, set up to a basic single view application, and inside here I can go and look for an image view. An image view is something that actually holds an image inside it. So it's not an actual image, but it will hold an image inside it. Now there's a lot of different ways of specifying what you want. Now if you see, I have a couple of images here. One is of the pasta and another one for salad. So I've downloaded these images and kept them here. I'm going to just drag them and drop it to my project. I just drop it here. Usually I create a folder called as images and then add it there. It asks me to copy items if needed. If I don't check this, what will happen is it will refer to these images on my desktop. And if I share this project with someone else, they'll not be able to access those images and it will give you compile time error. So I'm going to say copy items. What this does is it will take those images, make a copy inside my folder, and I can use them there. It says create groups, create folder references. You don't need that right now because there's no groups or folders you're adding, and add to target. So it's part of the 5th project that we're creating. Click finish, and now once the images are there, I can always go and look at the properties here, and it should show me the images that I added. So I can pick whatever I want. Now usually it stretches the image because it says scale to fill. I can just say aspect fit, so it looks perfect. There's a bunch of different options, you can try them out. And then I have that, so I'm going to select salad as my basic image, first image. When the app launches, I'll look for a couple of buttons. Add this button here, create a copy of this button by pressing option and then moving it here so they're both same size. Say salad. Second one, pasta. Move this exactly here using the guides. I'll try to keep it close to this as possible. So there you go. So what should happen is if I click on salad, I should see the salad picture. If I click on pasta, it should show me the pasta image. So by default, I'm gonna keep salad. Now to the next part, creating the outlets, which we have already learned quite a lot about. So let's see. I'm gonna go here inside the view controller file. First of all, I'll create outlet for my image here. We just hide this too. Control, click, drag, and leave outlet is what I want. I'm going to call it food image. That's it. My food image is there. I'm going to remove this function. I don't need this right now. I'm going to click here, press Control, and then drop it again here. And this time I want an action. And this action, I'm going to call it pasta clicked. Leave everything as it is. Next one, I'm going to say salad clicked. So both my, I created an outlet here. I'm going to go undo that. Get rid of this. Again, try that one more time. Action, salad clicked. Also, just to make sure, since I added and removed some items here, I'm going to go to my view controller and see if there's something additional that I don't need. I have food image, this, I have both my outlets, actions and outlets available. So that's good. I'm going to go hide this back. Now, once I have this, I'm going to go back to my complete single view, go to my code file and work on this. Now first, whenever pasta is clicked, what I want to do is I want to display inside food image equal to, so I can say food image is an image view, right? That's what we have. Now that has a property of image. So what image do I want to display here? So I'm going to say the image that I'm looking for is named. This is how you can specify, saying UI image named. What is the name of the image? Just give the first name. You don't have to give extension. And since this is for pasta, I'm going to select pasta. Same thing, I'm going to copy paste in salad. And let's run this project. See how does it look like. So it's running on my iPhone 8 here. It's going to take some time to launch this. And my 5th project, and I have my image view, which is an outlet, 2 buttons which has some action on it. If I click on salad, nothing will happen because it's already displaying that image. If I click on pasta, it will change to pasta image, salad. So this way you can add this different images and play with images and add whatever logic you want to add. So that's with our 5th project with images. 6th project, World Wide Web. Now in this particular project, what we're going to look at is how can you load URLs into your application. So what we're going to use in this particular project is we are going to use something called a WK Web View. It's more like a browser, but without anything, like no address bar, no back button, front button, just a web content place where you can actually load a particular URL. So that's what we're going to learn this particular sixth project. So now let's go back and look at our project. So I've already created a project here. In this particular project, I don't have anything. So I'm going to go ahead here, look for the web view or a WebKit view. There used to be a web view which is deprecated now. Since iOS 8, they came out with something that is called as WebKit view, and that's what we'll be using in this particular project. I'm going to load the WebKit view and make sure that it takes over the entire device. There you go. If I run this application right now, you'll see what happens. It will just crash your application. The reason it crashes your application is in this particular project, we are only using something called as UI kit that is available. So you can use all the UI elements. But if you see this, it belongs to something else. If you hover over this, you'll see that this belongs to something called as WK. Whereas whatever we used before, like for example, a label. If I click on that and get its information, it says UI label. Anything that starts with UI belong to UI kit. Now whatever we added here, which is a web kit, let's first create an outlet so you can see what it belongs to or what its name is. You already know it's a WK web view. Call it my web view, and it belongs to something called as the WebKit. So I'm going to go up here and I'm going to say import WebKit. Another thing that you have to do is go to the project, get rid of this, and at the bottom there's something called a link, framework and libraries. I'm going to go add, I'm going to look for web, and there you go. I'm going to add this WebKit framework. Let's run again. And now you'll see there's a white screen with nothing displayed on it. There's a web view here, but we don't see it. The reason we don't see anything is because we've not loaded anything on this particular web view. So I'm going to go back to my view controller, and here when it loads, what I'm going to do is I'm going to set my web view dot. So there are a bunch of different ways you can load things, but loading URL, what you would do is you'd call a function called as load, and it needs something called as a URL request. So for now, without going into much detail, I'm going to create a constant called as, let's say, my request, and set it to using URL request, and this request will need a URL, and that URL is, let's create a URL, my URL equal to URL, and I'll pass this a particular string URL, or let's see, string URL, and I'm going to call this https://apple.com, and pass this URL to this guy, pass this request to this request. There you go. So I created a URL apple.com, I created a request of its type and passed it to this guy. I have to make sure that this is having a bang operator, which means that I am sure that there is a value to that, and then pass the request to the web view. Now when I run this application, this open here and inside the web view, so it looks like a browser. It loads up Apple's website. If I click on things, it will act like a browser, but I can't change the URL or anything. Let's try some other URL. I'll go ahead and change it to my website, vivinarana.com. Run this again and see if it works. So it's installed the app and didn't load anything. So the reason it didn't load anything is Apple was a URL, SSL URL, and it recognizes the URL, but it doesn't recognize this website. So what you have to do is, for some of the websites, what you'll have to do is you go to info.plist file, add an entry here, and that entry is app transport security settings. So by default, Apple will not let you launch any websites that you want on your on the web view because it's a security feature. We'll go inside, add allow arbitrary loads, which means I can load whatever I want. This app can load anything that it wants on a web view, and when I run this, I will have it launch and it will load my website here, display everything here. Perfect. So that's how a web view works. Next, we'll probably do an assignment to see how we can use whatever we learned in this last 6 projects into an assignment. Tab bar app. Now let's look at how to create tab bar application. Now inside tab bar application, unlike what we have done before, where we created single view applications, where we added controls on it, in tab bar application it's a little different, where we have multiple pages, or what we call it multiple view controllers, and you can add them inside something called as a tab bar. And each and every tab bar will kind of control, or each and every tab will control one single view controller. So let's go ahead and start with an application. So I'm going to open my Xcode and I'm going to say create a new Xcode project. I can select there's something called as a tabbed application which is already available. Let's see how does that look like. I'm going to call it tab bar ready. Create. I'm just going to add it in my projects folder, and here I have the app delegate that we saw before. We have main storyboard, but along with that, instead of view controller, we have 2 view controllers, first view controller and second view controller. Let's look at the storyboard. So if you look at storyboard, what we have here is a tab bar controller, and if you see, it contains 2 different view controllers, one left and one right. So I'm going to go ahead and then just run this on my simulator. So what tab bar is nothing but, if I search here, this is how you can actually add a tab bar controller directly, and it will give you a couple of view controllers pre-built and you can go with it. You can try. What I'm going to do is I'm going to start with something that we have already done and kind of grow towards the tab bar application. So I have my first view and second view. This is how the application looks like, that comes pre-built as a template with Xcode. So let me stop this and create a new application. This time I'm going to go with the single view application that we're used to. I'm going to call it tab bar app. Save it. Now here, if you see, I have the same old files, view controller, I have my main storyboard. I'm going to go here, increase the size here. I'm not going to add a tab bar controller from the right here from a library. What I'm going to do is I'm going to select this view controller. It's another way of doing it. I say editor, embed in tab bar controller. So now this is embedded inside the tab bar controller. If you see at the bottom, it has that tab bar along with its properties. You can select what you want. If you want what a particular item that you want, there's a bunch of different predefined ones that you can add, or you can say that I want a custom one. And you can also provide an image if you have an image. We saw how to add images, so you can add images. The only difference with these images is these are glyph icons, which means they are particular type of icons. I'll show you what they look like. If you see here, not here, they're not actually I don't have it in this project, but in the previous project that we created, if you look here, we have these icons here. So when they selected, they look more like blue if you saw in the project which we ran already before. So if you see, they look blue and gray, so that's why they're called grayscale images or glyph icons. So you can use those. Now let's go back to our application and see how do we get to this particular stage using a single view application. So what we did till now is we already embedded our view controller inside a tab bar. I'm going to give it a particular text here. So the title right now is nothing. What it does is it takes the title of the view controller. So I can just go here. This is one way of doing it. Another way of doing it is if you select the tab bar here and then select a title saying, let's say red. I'm going to use 3 different colors, red, and I'm going to set the views background color to red. Make sure this is red. I can just do other and see 25500. That's how I know FF00 is red, green and blue. So I'm going to create 3 tabs. So since I already one view controller, I'm going to go and add another view controller, second one. This one I'm going to give a background color. Let's make sure it's selected. background color of green, which means that I'll have to go here, RGB, red is 0, 255 for green and 0 for blue. There you go. So I have green color. And the third one, let's add one more, and just add it below it, zoom out a little bit just so that all of them are in view. See, and this one I'm going to select blue by making red 0, green 0. There you go. I have my blue color, very bright. Now next, how do I add them as tabs inside this particular tab controller? If you see, they're not connected right now at all. I can select the view controller, press Control and then drag with my mouse and say this will be one of the view controllers. I can do the same thing. So this is connected. Now do the same thing again and say view controllers. Again, I can go to each one of these guys and set the title to green, next one blue. So I have 3 of them. Let's run this and see if we have our project with 3 tab bars ready. Let me just make sure that I select the same simulator that is already running. Installs the app and then runs it. So I have my red, green and blue. So if you see, there's no image displayed. This is just a placeholder on the storyboard, but this is how you can create tab bar controllers. So you have 3 different view controllers here inserted inside a tab bar, kind of a skeleton. Navigation app. Our next application that we'll look at is the navigation application. Now in navigation application, unlike tab application where you have one single tab bar application which has multiple tabs which contains view controllers, navigation application has only one view controller at a time, and you can navigate from one view controller to another view controller. Let's look at an example of how to set up a navigation application. I can start with the project. Now there's something called as a master detail application which comes with navigation application with it, but we're not going to look at it in this particular video. We'll look at the next one. So I'm going to do table views over there. So I start with a single application that we are used to. I'm going to call it a navigation app, save it, and next I'm going to go to my storyboard. I have my view controller here as usual, and I can just say editor embed in navigation controller, and what it does is it will put this view controller inside a navigation controller. As you can see here, it comes from here, goes to navigation. I can go to my navigation item here and I can say, let's say red, give it a color, background color of red. I'm going to make it a little bit lighter by changing the opacity so it looks reddish right here. So I'm going to say 25%. I'm going to put a button in here so I can show you how to navigate from one to another. We don't have to write any code in this one. It's pretty straightforward. I can say button that takes me to green. I'm going to add one more view controller, and then select this button and move it here and say show. So it will kind of, when you click on this button, will show you this green view controller. Even in this one I can go and so this is my second view controller. It doesn't have a navigation bar on top, even though it does, because it doesn't know where it comes from. So I can go to view controller and kind of set the title to green, and it will take that title. I can go to the view, set the background color to, let's say, green, or let's change the opacity so I can add the button. Can change the opacity to 25% and it has a greenish color over there. Add the button, or before that we add in the view controller. So we have 3 view controllers available. This one I am gonna open with a button which is right in the center. See, I'm gonna call this button blue. Let's move it to the center, and when I click on this, it should open this one, which you can set the color to blue. So it's navigating from red to green to blue. This background color I'm gonna set to blue by selecting this red 0, green 0, blue 255, and 25% opacity. So I have 3 of them. So now I have 3 view controllers. Let's look at how navigation controller looks like. I'm going to run this on my iPhone 8 simulator. Red, green, and blue. Opacity became too light. I guess I'll probably can make it a little brighter since the background color is much thicker here. That's why it's a darker color. So what I can do is I can just select this and make sure my opacity is, since the background is black, the opacity makes it much more the background of the entire application, and that's why it looks more on that. Let me just go back and move it back to 100%. Same thing for that. Green and blue. Here you go. Run this application again. There you go. Red, green, blue, and you can go back. One thing about navigation controller is you get these back buttons automatically. You don't have to do anything to code it. It kind of keeps track of each and every view controller that is there, and it stacks up on top of it. Unlike tab bar controller, where all the view controllers are available together in a particular navigation controller, you have one. Now second one is stacked on the first one, and the third one is stacked on top of the third, and when you press back, it pops them out, which means it just destroys them. It removes from the view, removes from the stack, and removes them. And when I click on blue again, it will recreate that view controller and add it back to the stack. That's how navigation controllers work. Table view app. We already saw how navigation and how tab bar applications work. Let's look at table view app. Table view app is something that has a list of items, or let's say table view, inside it, and you can add multiple items inside it. It's used quite a lot with a lot of different apps, and it's pretty much there in every single application that you'll build. So let's look at table view application. So I'm going to start a new project. So as I promised before, let me start with the master detail application, because this has both navigation as well as table application. Let's look at this template. Call it template. And if you see here inside my storyboard, I have master view controller, which is nothing but more like a navigation type of controller, which consists of navigation controller, and it has a table controller here. At the same time, it has more items at the bottom. Let me run this application just to show you how it looks like. So I'm going to open this application in iPhone 8. So it's launched here, and if you see, this is how a table view looks like. Along with the navigation controller, I can add more items. It's called master detail because this is more like an index type of application, where you have a bunch of items and you click on them, you see detail about that. So that's a template that is available to use, and you'll probably see them quite a lot in other applications. So let me go back and start with what we are familiar with, a table view app, a single view app. Call it table view app, save it, and inside my storyboard, I don't need the view controller, so I'm going to go and delete it, and instead of that, I'm going to add a table view controller. Make sure that this controller, let me just make sure that this one is the initial view controller, so I have the arrow pointing towards it. Now if I run the application as it is, make sure it runs on. So this is my application with bunch of items in here. Doesn't look good just by itself. That's why we see most of the table view applications, or ones that have table views, are embedded inside a navigation controller. So I'm going to do that. I'm going to add a navigation controller on top of it, and maybe add a title to it. Call it my table. There you go. Now it has different types of cells here. Now table views can have dynamic prototype, which means you'll have to code that and have similar looking table view cells, or you can always have static cells. Now inside my static cells it says that I have number of rows is 3, so I can create more like, I can add what type of content I want. If I look at this particular table view cell, it's of the type custom, but it has something called as basic, which has just that, a right detail, a left detail. So there's a lot of different options to look at. Pick one that you like. I'm gonna select basic. You can have like accessory type, which is the arrow that comes next to it, or a check mark, or a detail disclosure. I'm going to use this. I'm going to make sure that I have similar styles for these basic with accessory type of detail disclosure. This one I'm going to call it red, green and blue. Also it provides you actions, so without writing a single piece of code, I'm going to do all these things together. Add 1, 2 and 3 view controllers. Make sure that the first one has a background color of red, second one has a green, and the third one has blue. And now when I click on this, control and drag, it will say, do you want accessory action, which means if I click on this, that's when you want to show it, or when you want to show it when I click on the entire cell. So do that. Same thing for this. So accessory show, or this show. So I'm going to say segue show. Okay, and for this one, segue show. Let's run it and see what we have. So I have red, green and blue. It looks a little bit, doesn't look same like a table view, but if I increase the size, reduce it, the table cells are all there. Just the simulator doesn't render it properly, the cells. Red, green and blue. This is more of a static, but when you make real applications, you have a dynamic content, more like, let's say think about your address book. Depending on how many people you'll have that many items or rows inside a table. So that's how table view is used. Alert, alert, alert. Okay, so we have a lot of times in our application when we want to alert the user. Now there are different types of alerts, but what we're going to start with is a simple type of alert where we can display a message to the user, and at the same time we'll also ask for his permission for yes and no, and based on that take decisions. So like I can ask them, did you eat your breakfast, and they can say yes or no, or I can just say, oh, you need to have your breakfast, and then they don't have a decision to make over there, but just say yes or no in that case. So let's start with an application. I've already created an application. This is nothing but an empty application with nothing on it. What I'm going to do is I'm going to add a button to it, and this button I'll call it show alert in the center of the screen. Go ahead and make sure that it has an action here, and this action I'll call it show alert. Let's go back to the code, create in one single screen, and here is where we will add our alert. So what should happen is every time user clicks on the button, it should give an alert to the user. So let's make a simplest form of alert, which you'll probably never make or use. I'm gonna say the thing that we use is something called as UI alert controller, and to this I can add some, let's set these things as it is because we've not done anything in programming yet, so just follow along. I can say title is, let's say, breakfast. Message is have your breakfast. Now there are different styles. So for the first one, what I'm going to use is I'm just going to use an alert style. So I'm going to say dot alert, something like this. And then once I'm done with that, I can display an alert by saying self present and inside my present I need to pass a view controller. In this case the alert is a view controller. I'm going to show me alert animated. Sure, why not? True. I don't have to pass this third variable, I can keep it empty. There's a present with just 2 parameters. I can specify that and run it. Let's run this and see. This is the most basic form of alert and you'll never use it. The reason is, I'll show you in a second why will you never use it. Say show alert, it shows breakfast, have your breakfast, but I can't click on anything. If we make this application and submit it to App Store, Apple will reject it because there's no way for user to do anything or get out of it. There's different ways of doing that, but still, there is no easy interaction or a good user. This is not the good user interface. So let's go and add a button. So to add a button where I can just say to my alert, the alert that I created, I want to add an action to it. And this action is of the type UI alert action, and that is something that you add using UI alert action. And let's say need a, let me see if it can autofill it. Okay, there you go. Title is, I'm gonna say okay. Style, so there are different styles. There's default, destructive, and then there is something called as cancel. So cancel is a little bit more bold. We'll just use default for now, just to show you how it looks like. And handler is what you want to do once the user clicks on it. I'm just gonna say I don't want to do anything, so I'm gonna leave it null and run this application. Show alert, and it has okay. So just if you want a confirmation that user clicked on this action, you can pass something like create a block here, and we'll cover blocks later, but just to show how blocks work, I can say action in print, say good job, something like that. Run this. Now this will print in my debug area. So since I said print, so I probably see it here. Go here, say show alert, shows the alert, say okay, and when I press test okay, it's gonna show me good job, it ran this thing. So this is more like a block of code, which we'll kind of learn about it later. It's more of an handler, or you can think of it as an inline function, something like that, if you've never worked, but we'll probably look at that in the next section. So that's how action alerts work. Now I want to add a couple of more actions. What if I want to get a yes and no answer? So I can say yes, can say no. In case of no, I'll say I don't care about that, so I'm gonna set this nil. Can set one, just to show you the difference between the buttons, the styles. I can just say one is default, one is cancel, and you'll see what the actual difference between these two is. Show alert, yes and no. So if you see, this is more bold, this is not so bold. I can also use destructive for this. And when I say destructive, what it does is it adds a slight red tint to it. So that's how destructive buttons look like. There's no ordering of it, depending on which one you have. That kind of places based on the user interface of the button style. You can add as many actions as you want. It's not required that you need only 2 or 1. You can add more, and they will just line up one below another instead of showing it next to each other. So that's how alerts work. Lights, camera, action. So we saw alerts in the previous video. Let's look at something called an action sheet. Action sheet is similar to alerts, just that it comes from the bottom and it has a way to dismiss itself. What am I saying? Let's look at it. So I have my previous project where we saw alerts, which had a bunch of options over there. What I'm going to do is I'm going to take this button, create another one. I just have to press option and drag that button, and I create one more, and I'm going to say show action. Just to see it doesn't have that action that this guy has. If you see, this as show alert, and it also copied the same action. So I'm going to get rid of that. Go side by side with this view controller, and so I have my alert. Let's add our action function. make sure it's action, and I'm going to say show action. It might get confusing if I say action again and again, but yeah, it's IB action. So I created this. Here I'm going to just copy the exact same thing so it looks like an alert, but now instead of alert I'm going to say dot action sheet, and I'm going to get rid of these just to show you how it looks like without yes and no. So with alerts you realize that if I don't provide any action, it will just be in the center of the screen, and with action it shows from the bottom, and if I click anywhere else on the screen, same thing, nothing happens. Just doesn't have a way to dismiss it. So that's why we need these things. So if I add one, which is yes, show action, and it will have that property, and again, good job based on this. So it's not much different from alerts, just that it is the interface is a little bit different. So I can say maybe, and I can have, let's say this is cancel, and the order doesn't matter. What it will do is, if you look at it properly, the cancel, which is no, it's going to be sent below in a separate button, and rest of the items will display here. So that's how it displays, and this is how you can create an action sheet. And you probably have seen them quite a lot in different events. And whenever there's actions, you see one thing, you don't have to actually select them, you can just ignore by clicking somewhere outside the screen. So that's how action sheet works. User inputs and alerts. So we saw how to use alerts where user can only input whether, like, whatever options you provide, yes, no, some kind of buttons or some kind of interaction. But what if you want to take some more input from him, like his name, or enter something specific, a text that can be variable, or enter a number in there, which you can't give him the entire keyboard for input of, like, enter your age, enter your date of birth. So you want to give all these different options, then you probably need to add something into the alert. So I'm going to show you how to add a text field inside an alert. So let's go to a previous project where we had actions, we had alerts. Now next thing that I want to show you is, let's add one more button. Copy this one. Sorry, select this, and move it down. I'm going to say alert with, let's say, name. And go back here, make sure that it doesn't have that action, and I'm going to create a brand new action for it. I'm going to say action, I'm going to say alert input. So first thing that I'll do is, let's go back to the view Swift and get rid of all the other things. And inside my function, the first thing that I need to do is I will need to get that alert thing. So I'm going to get exactly same one, so alert, but instead of breakfast, I'm going to say what's your name. And I'm not going to give a message because it will crowd the thing up, so just set that to nil. Preferred action, I'm going to use an alert. So there you go. Next one, I'm going to add an cancel maybe option. I mean, say cancel to get rid of if user doesn't want to enter any information. And next, I'm going to add alert dot add text field. So you can add a text field to it. Inside this, I can say what I want for this part. I'll say that text field. So it comes with a text field. It adds a text field for you, and I'm saying inside the text field, what I want to do is text field in text field. So I think I have one extra bracket here. Say text field dot, let's put a placeholder over there so I can add properties to the text field here. Enter your name, more like that. And next I'm gonna say maybe an action, alert dot add action. So when user takes that action, what should happen? UI alert action. So let's say if he enters his name and says okay to it, so I'm gonna say title is okay, So you can do cancel, which will get rid of it. But if he enters his name and then clicks on OK, the style that I want is, let's use default one, and handler here I'm gonna set it as action in, and inside my action part I'm going to check if there's a value entered or not. So this is if let is just to check if user entered anything or not, which we'll learn more about in the optionals class in Swift. So for now I'm going to just go and say alert.text fields. So there might be more than one text fields, but I'm saying that inside my text fields, which is optional, because there might be or there might not be. So optionals are something that where you're checking if alert has text fields or not. So this is again something that we'll learn more in optionals, but for now just write it as it is. So I'm going to check what's the text in there, and based on that text I can say print welcome, and I can just take that name that I got from the text field and display it below here, some in the debug area. So run this application, or before that let's present this, or else we'll not see it when the button is pressed. My alert is, or controller is alert true, and as I showed you before, you don't need this, just 2 parameters are fine. Run this. So what will happen is it will first create the alert, add the action cancel. So if you just want to cancel it out and not enter anything, so cancel, and then next one it will add a text field, and whatever you entered here displays here as placeholder, and I have my OK button over there. So I can say OK, and at the bottom if you see welcome Vivin Arana, which is coming from this particular thing. You can give any type of message or use that text, save it in database, or do whatever you want to do with it. So that's how you can do an alert with input text field. Swift basics. So till now what we have done is we have created around 9 applications, and we don't know much programming. We started with making simple layouts, having some outlets, actions available to us, but we didn't code much, or when we coded we did not know what we were doing. So now is the time to look into Swift and dive deep and see what exactly Swift is made up of. So Swift is a new programming language developed by Apple, especially for iOS and OS X development. It's combination of both C and Objective-C with the best of both worlds. It's open source, so before when it was released it was not open source, and then they saw the community excitement and they kind of made it open source, just that everybody can contribute to it. It has safe programming patterns. When I say safe, it means that Swift eliminates entire classes of unsafe code. Variables are always initialized before use, arrays and integers are checked for overflow, and memory is managed automatically. Not like Objective-C where you had to make sure and keep track of things. Syntax is turned to make it easy to define your intent. Another safety feature is that by default Swift objects can never be nil. In fact, the Swift compiler will stop you from trying to make or use a nil object with a compile time error. This makes writing code much cleaner and safer, and prevents a huge category of runtime crashes in your applications. However, there are cases when nil is valid and appropriate. For this situation, Swift has another feature called as optionals, and we'll look at that in a separate section. So another cool thing about Swift is its modern programming features. It's a result of let's say a lot of research that Apple did, and a lot of other people came up with this, and they built this programming language. It combines with Apple building like really cool Apple platform apps. There are also something called as named parameters, which are bought from Objective-C, and you kind of write clean syntax that makes APIs in Swift even more easier to read and maintain. These inferred types makes code cleaner and less prone to mistakes, and we'll see it in the next video. Something like using variables and constants, it's much more easier to use. There's also memory which is automatically managed, and you don't even need to type semicolons. So it's pretty awesome. I mean, you don't know where the end of the line is. If you're kind of used to semicolons using C program, Objective-C, it will be a little bit weird in the start, but then you'll get used to it. These kind of concepts makes the language much more easier and fun to use. So let's start typing some Swift code. So let's go ahead and open Xcode. So Xcode will open up. First thing that we need a playground. So let's start with playgrounds because it's much more easier to play with it. We have blank option, we have game option, we have map options, we have single view, all the different. I'm going to start with blank for now and say next. I'm going to keep the name as it is, my playground, and press create. It's going to create a basic playground for me. It has the import keyword where it's importing a framework called as UI kit if I want to do something with the UI. So that's what this does here. There's a lot of different kits available, frameworks available. Next, I have a variable string that I've created and I've assigned it hello world. Actually, you see these things on the right side, but it's not displayed because it's still trying to process it. So I'm going to press stop here at the bottom and press play again, and it says running my playground, and soon you'll see the output of this line right next to it. I can create one more variable x equal to 10, and you'll see that being displayed on the right side. So this assistant video is quite helpful. Variables are something that we'll discuss in a minute, but these things I'm just going to get rid of it right now and then start over again. So let's look at comments. What comments are? Comments are very basic things in programming language, help others to understand what you are trying to do in programming. So I'm going to go for a single line comment. This is how we do it, backslash. This is a place where I will be write some code. Okay, and here I can add some code here. So it kind of gives you an idea of what I'm doing here. Then there's multi-line comments where you can have comments in multiple lines. It starts with /star, and this is a multi-line comment /star. So you can make it one line by ending it. So ending it is with star and slash. And what's happening here is just everything that you put inside here is a comment. So that's how you can create your comments. And now let's look at semicolons. Semicolons are optionals, as I mentioned before. You can add it, nothing will happen, it will not break your code. You can put it behind it or behind a variable or not. So it's completely up to you. How do you want to use that? Print statement. Of how we can add print statement. So I can type print how are you, and it will print in the debug area below here. It will also show me on the right side on the assistant editor, but that's one way of kind of printing it. You can print all different kinds of things inside your application just for debug purposes. Next, now let's look at constants and variables. So you have two different things. One is called constants, variables. As the name says, constants can never be changed. Variables, something that you keep on changing. To define constant, you start with let keyword. Let x equal to 10 is giving me error because I already have that variable defined. So I'm going to remove the previous one and let x equal to 10, x equal to 20. As soon as I try to change it, it will give me, the compiler will give me an error saying that you cannot do this. It's the constant. You can't change a constant. Whereas in case of variables, when you set some value to it, and you try to change the value of that variable, as in the name says it's variable, you can change the value of the variable whenever you want. I can add another constant to the variable, but I cannot change the value of the constant itself. Let's try to print this value, and as soon as I print a, it's thinking, and there you go, you see the value print. So now we know about print, constants, variables, and some of the comments. Let's look some more. So I'm going to go ahead, delete everything and start with a basic variable. So we created, let's say, variable equal to x. What type is it? Is it integer? Is it float? How do we know? So this is called as type inference, where Swift automatically will decide what it is depending on the value you assign to it. If I put something like this, it will take it as float. If I take it just number 10, it will take as an integer. If I write a text, it will take a text. If I want to create an array, I can always say that I want to create an integer array, and it creates an integer array. If I want to create something like key value pairs, I can also say integer, string, key value pair. So these are dictionaries in Swift. So that's how you can kind of create it. But what if you want to explicitly say what type it is? So you can always define, let's say x is of the type integer and it's 10. If you try to mess up with the system, it will give you an error. It will say that, oh, this is not a not an integer, it's a double. So what are you trying to do here? So I can change it to double and use it. I can also do that with booleans. I can say x equal to, I can say in this case I can say, let's say true, and it will have the boolean value of true or false. There are a lot of different values types, and then also strings that we have, so you can assign based on however you want. You can always specify what type it is by going here. So this is how you can kind of explicitly announce of what the types are, what does it do, and create some items. So you can always look at some of the array types. I can say where array, I can say that this is an array of string equal to, then I can say first, second. So what happens if I put a number in here? Since it's an array of strings, it will give me an error over here saying that what are you trying to do here. Similarly, for key value pairs, I can say this is string and the values are integers, and I can give key value pairs something like this. So it has key value pair items inside it. You can access them by saying a dot a of first, and what this does is this will access my a parameter, and then inside that what is the key is first. It will access that for me. Again, let's run this one more time just so that it displays the value here first, and we have a value 10 over here. So this is how you can access all the different variables, different data types, and that are available in Swift. Swift functions. Now we learned a little bit about Swift basics. What are functions used for? So if you have never used functions in your life, this is the right place to kind of start it. So let me go ahead and create a variable, or let's say create a constant a equal to 10. Let's create another constant b equal to 20. Now I want to add these two constants and add it to variable c. So I can say 10 plus 20, or I can say a plus b, and this will give me the addition of two numbers. Now if I want to keep on adding bunch of different numbers, instead of writing this again and again, what I can do is I can take these set of instructions and put them inside a function. A function is nothing but a bunch of instructions which can be reused again and again throughout your application. So what I'm going to do is I'm going to create function. To create functions in Swift, you use the keyword func. Pretty funky, huh? So I'm going to say add two numbers. That's what I'm going to call it. And functions actually close with bracket. So this is a very simplistic function. Out of all the things that we're going to learn about functions today, this is the most basic function. This function, what it does is it just adds two numbers. So I can copy this or cut it and put it inside here. So this function adds two numbers. If I say add two numbers, what will happen is it will take these and then kind of call this function once. If I call it twice, you'll see it will say two times, three times. So you can call it again and again. But what is the difference between what we did here and what we did before? Nothing. And it's giving me a issue here saying that I'm not using C, and why am I creating a variable? So I'm going to just, for fun, I'm going to just print it out. So now if you see, it is printing three times. So three times here. So 1, 2, 3. If I remove one of them, it will only print once. One more removed. So I have only one time going through this function. So this is a basic simplistic function. Now this doesn't solve our problem, where if we want to add two numbers which are different and not 10 and 20, what is the use of this function? There's no use of this function. So what I'm going to do is I'm going to give it some input. So I'm going to say you have a as an input, which is of the type integer. You have b as an input, which is of the type integer. So I'm saying that you are taking these two arguments or parameters. That's what these are called. So you can say that I can give you two arguments. So instead of defining them or hard coding them, what I'm doing is I'm making them kind of input variables which will be passed to this, and that is what is printed. So again, when I call this add two numbers function now, so if I say add two numbers, it will ask me what is the value of a. So I can say 10. What is the value of b? I can say 20. It takes these numbers, gives it to this function. So a's value is 10, b is 20. It puts it in C, plugs it over here, and I get the answer 30 as before. So same to same as before, just that this time now I can use this for multiple purposes. I can say, hey, okay, how about 5 and 2. So now the output should be 7, and that's what I see here. So this is what functions are mostly used for, to kind of group some similar code into one single place and then use them throughout your application or throughout your program. So that's how functions are helpful. So now we saw a basic function. We saw a function where it takes two inputs, which can be whatever you want to send it to. Another thing is, what if I want it back, or something that is called as return back from the function. So I can always use this arrow sign, and then I can say it is going to return back an integer. So that means this function needs to return something back. So let's say if I want to return this C back, so I can just say return and C. So now what it does is, it will take these two parameters and return it back to whoever is calling it. So if you see here, it says 30 and 7. I can put this inside let result equal to let second result equal to. Now I have these values inside this, and I can, if I want to print it, I can print result, and I'll see that result out here. I can do the same thing for second result, and that will be available here. So this is another reason why you can use it. You can pass some values, do the calculation somewhere else, and it will get back the result. One very popular thing that most of the applications do is, you say that, okay, I want to search for, let's say if you go to Google and say, I want to search for restaurants. You put restaurants in there. So what Google does is, it takes that restaurant, puts in a function, finds in its database all the restaurants around you, and then gives that back to the browser, and the browser displays it. So you can think of Google is running a search function with the query that you passed, and it returns back to the browser with the result. So that's what functions are used for. Another thing that I can do is, this is very special in Swift, is tuples. Tuples is nothing but returning more than one item from a function or a variable. You can say let result, and this can be of a type tuple, RSULT, because I didn't want it to use the same parameter. It is of the type int and of the type bool. So I can create something that is of two different types. I can say for 2, true. So this is more like a tuple. So how do we return back a tuple? So to return back a tuple, all you do is, you define the tuple structure. I say I am going to return an integer, and I am going to return a bool. So there are two different things that are being passed back. So now it will give me an error saying that you're returning back only an int. Where is that bool? So I can always say C, true. And now I will have two parameters returned back to me. If you see here on the right, we have 30 and true, 7 and true, and this is the print result 7 and true. Now it doesn't make any sense. What is this used for? Let's write a if loop. So if you're not familiar with conditions, we're going to look at that later. But what I'm going to do is, I'm going to say if C is greater than 30, or let's say 20, then I want to return this. Just make sure I put brackets. Else, or I can say return false. So what's happening here is, as and when this goes through, it is going to check what is the value of C. In this first case, it's 30. Is 30 greater than 20? It's going to return this back to this guy. It's not going to go ahead and execute any other lines. Whenever a function meets a return, it will just stop doing everything it's doing, and no other lines of code will be executed. Just come out of the function and return you the value. So that's why you see 30 true here, and this is 5 plus 2 is 7, which is less than 20. So it's not going to execute this line. It's going to directly jump here and return this, which is in this case 7 and false. So that's how you can return it. Now if you see something here, it says this tuple is 0.0 and 0.1. What you can do is, you can name the tuples. I can say sum, and I can say, just like A and B, we can say sum is greater is bool. So now I can say is second result dot sum, and it will just print out the number 7 right here. If I say is greater, it's going to tell me true or false. So this is how you can kind of dismantle a tuple, and you can have more than two values inside tuple, and you can use them for a bunch of different reasons. It can be similar to, like, in previous other programming languages, or in Objective-C, we would return back an array or a dictionary or a bunch of different items inside it. In Swift, you can do it much more simpler by just using tuples in there. So this is all the things that are there in functions. This is how we do functions, and we will learn more and more as and when we write more applications. So we're going to learn more about functions, we'll learn more about all the variables, constants, or how to use them as and when we get our hands dirty into programming more applications. Swift optionals. So what I've done with Swift optionals is I've divided into 4 different sections. The first one is Swift optionals introduction. Then we will look at unwrapping optionals, and then chaining optionals and guard statement. What are these? Let's dive deep and see what these mean. Swift optionals. Optionals are a powerful feature in Swift language which helps you with non-existing values, meaning nil values. Optional is just like any other type in Swift language. Think about string and string question mark, also called as optional string, which are 2 different types. If your variable is of the type string, you know it will always have a string in it. And if your variable is of this type string question mark or optional string, it will either have a string value or it will have no value at all. In other words, it will be nil. Think of optional as a box of cookies. This box of cookies might have cookies in it or maybe not. That's why the question mark at the end. I know it's a terrible thing to have no cookies, but example, it happens. Under the hood, optional types are just enums with 2 cases. None, meaning no value is set, and some, meaning the value is set and its value associated with it. Let's look at some optional examples. I've already created a project, a playground. Can't call it a project. Swift optionals. So I'm going to go here and create a variable number of cookies. Now if I set something like this, you're used to it, you can give a value 20, but if you want to make it optional, you can do something like this, and it's optional, and you'll see that the value is nil to it. If I remove the question mark, it's still, if you see, it's nil, but this will help you in future kind of to set the values or tell you what it does. So I'll kind of go over it. So I'm going to give a value of 20. I'm going to create one more. I'm going to call it name of cookie. Inside this, I'm going to make it of the type string question mark. So this is how you create optionals. Now let's print something so I can show you how optionals are helpful. We have number of cookies of type, and I'm gonna say name of cookie. So now when you print it out, you'll say we have optional 20 cookies of type nil. Since this value is nil, is showing you nil over there. If I remove this, if you don't set it as, it will give you an error. So you get a runtime error, right, or compile time error right over here saying that, oh, you're trying to display something which is nil. Are you sure? Because it needs to have a value. So by creating it optional, you can actually have it as a nil and still have that variable available. But the problem here that you see is the optional 20. So what's happening here is it's printing optional 20 because it's a variable inside a wrapper, just so that the application doesn't crash. We will learn in the next video of how to unwrap these wrappers. I hope you will see the importance of these optional types. So what happens is, the reason it's optional 20 is because it's actually a box of cookies, or let's say this is a cookie which is wrapped inside a particular optional. So it's a box. So we'll see how to open the box and get the value out of it, open this box and get the value out of it in the next chapter. So that's about optionals. Unwrapping optionals. So how do we unwrap optionals? In the previous chapter we saw that how we can create optionals, or in this case I would say we kind of protected a variable by putting optional property to it. So how do we unwrap these optionals that we created? We saw how it prints out, it says optional 20, and that's not what we want to display to the user. So because compiler doesn't know how to add a box into a type or remove it for that matter, in order to achieve this, we need to unwrap the optional. In other words, we need to open the box and extract the value inside. For that, we put the bang mark or exclamation mark after the variable's name meaning. So what I mean is I'm sure this box contains something. Extract that value and use it. So that's what exclamation means. So in that case, you are actually force unwrapping, or you're forcing it to give the value. So it's generally a very dangerous thing to do that, because the box is empty. Because the box is empty, the app will crash at runtime. So it's more like, you're trying to give a box of cookies to a kid, and when you're force unwrapping, you're saying that there are cookies inside it. Whereas if there's no cookies, the kid will just start out crying. So that's more like an example with this. So when you're forced unwrapping, you have to be very careful that it has a value, or else your app will crash. A good practice is to check for nil before unwrapping. Let's look at an example from a previous project that we created, or playground that we created. So this is what we had, and we saw that we have optional 20. Now one way of doing it is forced unwrapping. You just do this, and you'll see, there you go, we have our number of cookies displayed properly. So that's how you forced unwrap things. But why don't we always forced unwrap? Like, for example, this guy is showing me nil here. If I forced unwrap this one, it's gonna, so if you see here, there you go, error, unexpectedly found nil, because you're trying to force unwrap this variable and it is nil, and it's gonna crash your application. So that's not a good practice to use forced unwrapping unless you're 100% sure that there is something. For this variable, we will have to check if the value is nil, and can't use forced unwrapping since it will crash. So optional binding is another way of opening the box. It allows to check the optional and get its value into a constant or variable as part of the single action. So we'll see how to do that. It's useful when we need to use, say, the unwrapped value many times in the if body. So let's look at how we can do this. I'm gonna comment this out just to compare at the same time. So I'm gonna say if let, this is how you kind of do optional binding. So I'm gonna say here, so if let, and I can create the cookie and give it name of the cookie. So what I'm doing is, if let, what it does is it creates a variable. So it creates a constant in this case and assigns the value of here, this to this. So if this value exists, then what do I want to do? So I'm going to go here and I can print this variable, this entire line here. So that means that I have, so instead of this, I can use this now because that's the value there. So I'm saying if the value exists, I want to do this. Else, since I don't want to display nil, I can just tell them that we have, so since only this value is there, it's going to go inside this and then unwrap the value and say we have 20 cookies. But if I assign it, say I have awesome cookies, if I can spell that right, okay, awesome cookies. So now it will go inside this one. It says print we have 20 cookies of type awesome. Or if I don't have this, it will just skip that first line and go to the second one, and it will display how many cookies we have. Here we didn't use the exclamation mark after this. That's because it represents that the already unwrapped value is what we're using, which is the cookie. So we just unwrap it once and we can use it multiple times in the if body. So if you see here in this one, we have done it because we didn't unwrap that. We can kind of use the same thing for this guy too, but that's how you can do two different things: forced unwrapping or optional binding using this if let condition. Chaining optionals or optional chaining. Optional chaining is a feature that allows to call properties and methods on an optional that might currently be nil. It's like asking our cookie from previous example if you are crunchy or not. If the cookie doesn't exist in the first place, forced unwrapping will result in a runtime exception, whereas optional chaining fails gracefully when the cookie is nil. Let's take another example. You may or may not have breakfast today, but breakfast does have food in there. So if we want to check what is the food options available for breakfast, we might need to first check if you will have breakfast or not. And in case you do, we can also figure out food options. Here's where optional chaining and the idea of using the wrapper without opening it comes into action. Let's look at this example in action. So I know that we have not created any classes yet or learned about Swift classes, but for the sake of this example, we'll be using classes here. Classes are just representation of items we are using in our code. We can probably, or you can visit back this course after we finish class, but class just kind of is a blueprint. So let's try and create a person. I'm going to keep it as simple as possible with classes just because we have not covered it yet. Now this person has a property inside it called as breakfast, and I can say that this breakfast is not a string or not anything, but it's of the type class. So you can have one class belong to another class, and that breakfast class is coming up right here, breakfast class. So this is how you can create breakfast, and this person has breakfast object which is this class. So you think of it as if this is the class string that was created by Apple and you're using it, same thing is happening here, and I'm creating this breakfast as optional. Now I can set food options. So what all different food options does my breakfast have? So, or how many of them do we have? Just to keep it simple, I'm going to keep it int type. I can give it optional value too, but what I'm going to do is I'm going to say that this has 0 food options by default. So that's how I'm going to set it. So I have two classes. One class is breakfast class, which has a property food options, and it says it has 0 food options by default. So if you create a class or a variable of the type breakfast class, it has 0 food options by default unless you set something. And then person has a property of breakfast which might be a value or might not be a value, is nil in that case. So that's why it's optional here. So let's go ahead and create an object of the type person. So I'm creating a constant, and I'm saying this constant is person. This is how you can create a new object of a particular class by saying the name of the class and brackets around it. So this creates an object of this particular class. Next, I'm going to say if let, that we used last time, food options. So I'm saying let's look at food options, and food options comes from, so if you see here, I'm going to say person, which I know is a object, so it is not a nil. I'm saying what is the breakfast that you have. Now if you see in this case, this value can be a value or not a value, so I'm going to put a question mark, and then I can say food options. So this is how I can get food options. So what will happen is, first it will check, we know that the person object exists, so it's not going to crash here, or else if this was an optional too, we could have put that. I'm saying dot breakfast, so I'm checking if person has a property breakfast. It might have a value, might not have a value. If it doesn't have a value, it will just quit right there. But if it does have a value, it will check, oh, what are the different, how many food options does this breakfast have? So that's what happens here. So I'm going to go ahead and print something. Say person has food option. Just to not confuse it, I'm going to say how many food options. Person has how many food options for breakfast. So if it has a number, it will give me that number. Now in this case, it will not print out anything. The reason being, as soon as it checks person, does this person have any breakfast or not? It didn't have a breakfast, so it's going to just stop here and then quit out of it. So I can just say else person didn't have breakfast. Sad face. So if you see, person didn't have breakfast, sad face, that thing came out because as soon as it went here, it said, oh, this person didn't have breakfast. So it didn't even go into the optional chaining, the second part of it. So what I can do is, I can say person did have breakfast, and to do that, to give it a value, I can say, can create an object of this. This is one way of doing it. Another method of doing it is you can create an object of type breakfast, and I can say this person had this breakfast. So there are a bunch of different, either use the shortcut or define all your variables properly, and just in case if you want to use it. So if you see here, person has 0 options for breakfast because it always has a value, so it doesn't matter. But the previous case there was no breakfast object itself, so it didn't even have breakfast, so it would not even go inside the food options. This time it had person, it had breakfast, so it goes one at a time, and then as soon as it reaches here, so it kind of, if something is not working properly, it will gracefully exit and go into the next object. I can also set and say here breakfast dot food options equal to, let's say we give the person 20 different options, so it says person has 20 options for breakfast, because we are setting a property of the breakfast food options to 20, so it will override this 0 and set 20. So that's how optional chaining or chaining optionals is helpful, where you can kind of go at each object at a time and then see if that exists or not. So that's how optional chaining works. Next we'll look at guard statements. Guard statement. You can think of guard statement as if statements with an attitude. Like an if statement, guard executes statements based on a boolean value of an expression. Unlike an if statement, guard statements only run if the conditions are not met. You can think of guard more like an assert, but rather than crashing, you can gracefully exit in this case. In case of guard statement, if the condition passes, the optional variable is automatically unwrapped for you, which within the scope that the guard statement was called. So it kind of automatically unwraps the value and gives it to you, just like if let that we used before. Guard statements are very handy for error handling in long run by setting up requirements in your code and making sure that you don't have any unforeseen errors down the line. So it kind of helps you more like a test-driven development kind of environment. And guard statements, and I mentioned it does unwrap optionals much like if let. The only problem with if let is if you kind of chain options over and over again, there is a problem called as pyramid chaining, where you have a pyramid of doom where you can do if let over and over object. If it's a deep object, you kind of keep on doing that and you can get into trouble. So that's where guard statements are more handy, because guard statement lets you decide if it returns, so it will let you gracefully exit if it doesn't exist, and you don't have to go inside. Whereas if let, you have to kind of dig into it one after another just to see if the optional value exists or doesn't exist. So let's look at an example. I created a playground and we are going to use functions. We have not done functions yet, but let's add a code inside a function here just to see how it works. So usually functions are set of commands that are returned together, or set of code lines that are returned together, grouped together in one particular place. So I can show you the basic definition of function. So I can do something, think function here, how you create a function, and we'll learn it in the next section. And to call this, all I have to do is, this is how you call this function. So usually this function will not run if you don't call this function. So inside this, let's say I can say hello world, and it will print hello world because I've called it. If I don't do anything, it will not print out anything here. 1, 2, and come on. Okay, so if you see, doesn't print anything. But when I call it, so let's say this function do something function has a variable meal, which I'm not sure that exists or not, so I'm going to create it as optional, and I'm going to give it a value. Let's not give it a value. Let's say it's nil. I can use a guard statement here and say let the meal equal to meal else. So if you see in this case, you give the else before and you go inside this else case if this meal doesn't exist, whereas in if let, you go if the value exists. So here I can say print no meal, and then I can just return out. This is how you get out of the function. And if it does, if the meal exists, I can just say print the meal. So if you see, the variable also exists afterwards, whereas in the case of iflet, the variable doesn't exist outside the iflet. The scope of the variable is just inside where you say if I say iflet, the scope is just there, whereas in guard the scope of this variable is outside and not inside. It will go inside this only when it crashes. So you can think of something like iflet a equal to b, and then you say iflet, and you keep on going. So this is, if you look at it sideways, it becomes a pyramid of doom. So that's why it's called pyramid of doom. Now in this case, since it doesn't have anything, so it says oops, no meal. But if I give a variable to it, I can say I'm gonna have a breakfast. So now it will not go inside this else statement, it will jump outside and go in here and display the print. So since it's giving me a warning here, since this was never mutated, never changed, so I can always give it a constant and it will not give me that warning too. So there you go. That's how guard statements help you from writing bad code and have a better, it will not crash your application if some variables are nil. So you kind of do a check, or you guard the particular object that you're using. And that's it for guards. Swift classes and structs. So for this particular section, what I've done is I've divided classes and structs separately. So first we will go over Swift classes, where we will cover basic classes, class methods, and then subclasses. And the next section we'll do Swift structs, where we will have basic structs and then struct methods. Basic classes. Classes in Swift 4 are one of the building blocks. Just like constants, variables, and functions, the user can define classes and their properties and methods. Classes are just like recipes. You can see them, you can read them, but you can't eat them. They are the blueprints for the actual food, which in programming world is also called as objects. So classes are nothing but blueprints of the objects that you create using these classes. It's just a symbolic representation of objects that you would need. So you would probably architect the entire blueprint and then provide it to your code so they can actually use it. Swift allows us to create classes as a single file, and the external interfaces will be created by default once the classes are initialized. You can also create classes as subclasses of other existing classes, which means you can take a recipe and then create your own recipe by adding more steps to it. You do not have to recreate a recipe that has already been created, and we'll look at subclassing a little bit in further. One important thing to remember about classes is the objects created are class by reference, which means pass by reference, which means when you pass objects to other objects, you're passing a reference to the location of the object and not the actual value. Let's create some recipes. Let's create some classes. Let's go open Xcode, and I'm going to start a playground and call it classes. And remove everything over here. Now class with, as I said, let's create some recipes. Let's create a class recipe and give some things like name of the recipe, which is a string, can associate number, the amount of time to cook this recipe is probably int, and variable time already spent cooking this recipe. We'll also keep track of that. I'm going to set that as int, and you can also have some predefined values, like for example maximum spice level, which is integer, and I can give it some value as soon as I initialize it as 5, let's say 125, 5 being spicy. Now if you see there, it says class recipe has no initializers, so by default you'll have to provide some type of initializer for this particular class. Classes needs initializers, structs don't, and we'll look at structs later, but classes do need initializers. So I'm going to create an initializer, and the parameters that we need are the parameters that are passed. So I'm going to give name, say string, so whatever we have on the top, time to cook is int, and time taken again in int. So I provided these. You don't have to provide this because it's already been initialized, so you don't have to kind of initialize values which don't already available. So I'm going to say name equal to name, whatever is passed to me. Self dot time to cook equal to time to cook. Self dot time taken equal to time taken. So that's kind of gets all my values in place. Now there's also convenience initializers. This is the kind of delegated initializer which you need to be there. So every single class has a default initializer which needs to be there, and that's this initializer. And I can provide my own convenience, which kind of helps me while I am initializing some objects and some values are default. For example, I can create an initializer with name and time to cook as requirements, and then I can just say call the init method, and I can pass the name that I got, cook, time to cook that I got, and default I would say every single thing that or time taken is initially 0, because when you start a recipe you're not started anything, so time 0. So I can set something like this, which might be very helpful while you are coding something. Other than that, we also have computed properties. So we can have a computed property. For example, I can say time remaining to cook can be of the type int, which can be more like time remaining to cook is time to cook minus time already taken. So this is something that we can compute in here, so that makes more sense in here. Other than that, we can also have something with with properties which have getters and setters already been initialized here. So I can have, let's say, get, and I can say return time taken. So this will give me, and I can set my time taken to be new value, whatever is available. So that's how you can kind of have getters and setters for your properties available over there. Let's go ahead and take this class and then create some objects out of it. So as I said, this is the blueprint, this is the actual object that I'm creating. So let's say I want to create fried rice object. So the recipe for this is just some space, can use default initializer, which is, can say fried rice. Time to cook this takes, it's around 30 minutes, and time taken already finished, I said 10 minutes since already in the process. Can give some values to it. I can also create more items, like for example I'll say using for the convenience method, can say lentil soup equal to recipe. I've not started making it, so I'm gonna say its name is lentil soup, and time to cook, let's say it takes 20 minutes to cook, and I don't have to provide how much time it taken, because it will take this time taken as 0 since I've not yet started cooking, and it can keep on giving me values. I can print some values out. So for example, I can say fried rice dot, let's say time remaining to cook. Since it says 30 minutes and 10, so 30 minus 10, so it should give me 20, and that's what I get here. So this is how you can use your classes. This is the basic representation of a class with all the different things that you can do with classes. We can look at more on class methods and how to subclass in future, but this is a basic representation of a class, a blueprint, as well as a couple of objects that we have created using that particular class. Now that we know what classes are, or just recap, classes are nothing but blueprints from which you kind of create your objects, or classes are just like any recipe from which you can actually cook food and then have some real food objects in front of you. So let's look at class functions or class methods. What are different methods, or how to code that? These are functionalities that can be added to your classes and will only exist inside your classes, which the objects which are created from the classes can use. For example, let's go to our previous code that we've written, and if you see there's no functions inside here, I'm going to add a couple of functions here. So I can just say func, can say cook for is a function, and it will be passed. I'll have some minutes available. Say how much minutes do you want to cook this item for, and I can increase the, let's say self.time taken plus equal to minutes. So I'm incrementing the time that was passed to me and take the time taken, and whatever time was passed to me, I increment the classes or objects time taken by that many minutes. Another thing I can write is what's the name of this dish, and I can just say that this is a function that provides me a string object pack. I can just get the name from here, but this is just another way of doing it. So I can just say self.name, and this will pass me back the name of the dish that I'm looking for. So let's go ahead and modify some more things here. So I'm going to remove this print statement, and now I can say more like time remaining to cook. Let's say I can say fried rice. Let me close this so it's easier. Fried rice dot, I can say what's the name of the dish. So time remaining to cook fried rice is, or I can just say colon and say fried rice dot I can say time remaining to cook. So this will tell me, this is kind of going to print me time remaining to cook. It's going to call this function, get the name fried rice is 20 minutes. Why? Because I say time 30 minutes and already I have taken 10 minutes, so left is 20 minutes, and that's what I get back. Now I can say, go ahead and say fried rice dot cook for another 10 minutes. So this will call that function, cook fried rice for 10 more minutes. Can print the same thing here, and if you see, after calling this function, it will update that and tell me that cook fried rice is 10 more minutes. So you can use functions to kind of make sure that you update some objects, or do some calculations or math on the objects that you're working on. So that's what class functions are. And next we'll probably look at subclasses, which will help you create more customized classes from existing objects. So I guess you understood how to write functions, or what to do with the functions in a particular class. Swift subclasses. So now that we have seen how to use classes, how to write functions inside the classes, the next thing that we have is subclasses. Now subclasses is an idea where you already have a class defined which does everything that you need to do, and you want to kind of add some more functionality or create a class that has something more to it and can't be added to the existing class. For example, if I have a blueprint that is already been built for most of the things that it already does, and I want to add some extra things. For example, I can give you automobile. Let's go for a change. If I have a car class, the car class says that it can drive, it has 4 wheels, it has 2 doors. Now if I want to make a sports car, it does everything that the car does. Why do I have to define all those things again? So instead of that, I can just use that and then kind of add more functionality to the new blueprint that I'm building. Or you can take again food examples. You have a class or recipe which can get you cook rice. Now there can be 2 different subclasses to it. One is a steamed rice, one is fried rice. The only difference between that is how do you what additional things that you do in your new class, which is steamed rice, where you steam the rice, whereas in fried rice you take the existing rice that is cooked and fried. So that's additional functionality or a new blueprint that you create based on the existing blueprint that is there. So that's what subclasses does. And let's look at how we can start with subclasses, and also then see how we can override some methods inside a subclass. So I'm going to start with the project that we already have created, the recipe project, and I'm going to go inside here. I'm going to get rid of this thing which will cause me a bunch of problem. So as soon as I add this, it will say that, okay, first of all I need that int, and then my default initializer is missing that particular max spice level, and I can set that to int, or I can just say spice level. You can say self dot spice level equal to spice level, see where else, and here also can give a default value, but probably go this dot spice level is int. You can say spice level is spice level provided. Once that is done, when I create here, I'll have to probably pass the spice level. Let's say this is fried rice, spice level is, let's say it's a 3, and here I can say spice level is more of a 2. This lentil soup is not that spicy, and we have everything working perfectly fine. Now I'm going to create another class here. I'm going to call it spicy recipe. Now recipe. So now if I want to create a recipe which is spicy recipe, which is same as the recipe, all I have to do is I can say it does everything that the normal recipe does. The only thing is it has one more parameter, which is type of pepper that I'm using. What pepper do I use in this particular recipe? That one doesn't have it because it's just a universal recipe for everything. Again, the problem is need an initializer, so I can create an initializer with all the parameters that the previous function needs. The only thing that changes is it also needs type of pepper, since it's not initialized, and just a string, so it's not initialized, so I'll have to provide that. And here, I'm not overriding, just initializing. Now here again, same thing. The only thing that I need to change here is type of pepper equal to the type of pepper that is passed. Rest of the stuff I can just call the super, which means the super class for spicy recipe is recipe. So I'm going to call this method, which already associates everything over there. So I can just say super initialize. I have the name, I have time to cook, I think I'm missing, let me see, time to cook and time to cook, time taken, and spice level. So I think I picked the wrong one, so I can just say time taken, and spice level is spice level provided to me. So this is how you can kind of create a new class, subclass from the existing class, and give its initializer to it. Now I can update this cook for method here. I can also say, so if I say function cook for, and say it does exactly same, but let's say this one, time taken plus equal to minutes, whatever is passed, plus 5, whatever is passed plus extra 5 is what I would want to add to this. Now if you see here, when I do this, it says, oh, you are overriding a class that is already function that is already available over there. So all I have to do is say override function. So that means whenever a spicy recipe object is calling cook for, it was going to call this function and not the one above. So if I make a new object, let's say if I make what should I do, what should I come up with, something spicy. Let's see, how about jalapeno poppers. It's filled with hot cheese and it's jalapeno. So I'm going to say this is of the type spicy recipe, and let's give it all its objects. Just copy paste it here, jalapeno poppers, and time to cook, say 20 minutes, time taken 0, spice level I'll bump it up all the way to 5, and type of pepper is, say, jalapeno. Now when I use something similar here, let's say time to cook, jalapeno peppers, what is the name of the dish, time remaining to cook. So if you see, it uses all the functionality that the parent class already provides. Now if I say jalapeno poppers dot cook for, let's say 5 minutes, and to this Now if you see here, I said cook for 5 minutes and initially it says 20 minutes. So if I've added 5, where the extra 5 came from? Because it called this function, and that's why it shows 10. If I remove this function from here, it will call the parent function and you'll see the change in a minute. And if you see, it says 15. So when you override something, it's gonna ignore the previous function and take this one, not the parents but the current object's classes function, and use that instead of the previous one. So that's how subclassing and overriding methods kind of helps you write some specific code to a new class that you defined, or a new recipe in this case defined. So that's how subclassing works. Okay. Basic structs. Structs are very similar to classes as per the syntax and functionality go, but the only difference is structs are passed by value and not passed by reference like classes, which means when you pass a structure to someone and they modify, the value of the actual struct doesn't get modified. So structs are used for simple instances, whereas classes are used for complex instances. Structures are well suited for when instances don't need inheritance or reference capabilities. So you can think of classes as a buffet where every person can go and pick their food, where whatever they do impacts the buffet, whereas structs are more likely like ordering from the menu and everyone has their own item even if they order the same item. So that's how I can think of classes and structs. Also, structs come with the default initializers, and you don't have to create initializers like in classes what we did. You can still create initializers if you want, but it sets the basic stuff for you. If you want to do something more in the initializer, then it's a good idea to create your initializers in structs. Let's go ahead and cook some structs. So see, let's open Xcode and let's start with the blank project. And I'm gonna kind of create a struct with the same name, recipe, and this struct has variable name, and this is of this type string. I have another one which is description, and I can have something similar to what we had in classes, where I can say time to cook, the type int, and we can give it value right here, return 30. So you can actually initialize something using this kind of fashion, or you can directly give value to it, assign some value to it. Now let's go ahead and use this. Create my food item equal to recipe, and if you see, I had not created an initializer, but when I say recipe, it will give me this value, so it automatically creates it. So I can say spicy cheese sandwich. What is it? It is a sandwich which with cheese and spicy Tabasco sauce. That's what this contains. I can look at it. I can say my food dot time to cook. It's gonna give me the same value that I've assigned here, and so if you see, 30 minutes is how much it times to cook this particular one. I can give the name, and that's how kind of structs work. It's much simpler. You don't have to do initializers or anything, but the only thing that you have to remember is it's passed by value. So when you pass this to someone else, they can do modifications and nothing will happen to the actual object that you have in hand. So whatever is passed as a different is just like other basic default types or primitive types where it's all passed by value. Struct methods. Now it's similar to class methods, but so you can add your own classes, but there's something catching about this thing where since you're passing the value, there is a catch about the structure being mutated or being changed. So you have to take care of some items when you're working with struct methods. So let's go and look at our existing example that we created for struct, where we created a recipe with one object here, which is my food, and then we kind of added this. Now let's add a function to this. Now whenever I add a function to my structure, let's say I want to change the description of this object, and I have to pass the new description, which is a string. So since I'm changing a particular parameter, for example in this case I'm changing the description to the new description, it's going to give me an error as soon as I save it, saying that you cannot assign property to self which is immutable. So since a structure is passed by values immutable in nature, so it can't change. So what you have to do is to specifically say that it's a mutating function, so it will kind of change the value of your particular structure. So this is how you can kind of take over changing parameters or changing the variables inside a particular structure. Now I can go here, can just say my food dot change description not so spicy sandwich, and now when I look at my food dot description before and after, you'll see it let me change it. If I remove this, it will probably not even compile, because it's going to give me an error saying that you're trying to change something that is part of the structure and you're trying to modify it. So this is something that you have to be very careful about and use it very carefully. Unless it needs changing, you don't have to change it. Also consider using classes in this case if you have to, but that's an option that you have to remember about, and we're going to use this quite a lot in future. So that's about using methods in structs. Swift protocols. So for protocols, what I've done is I've divided it into 3 different parts. First, introduction. Next, we'll go over protocol extensions, and then we will look at protocols in structs. Swift protocols. Hello and welcome to Swift protocols. In object-oriented programming, a protocol, or sometimes also called as an interface, is a way for 2 different objects to communicate with each other. In a protocol or interface, you define methods and values which the objects which use them, or say objects that follow them, implement them, just so that they can communicate with each other. It's more like saying when you cook something, it's a protocol or a rule that you follow a particular recipe. You do not go and add spices to your ice cream, or say have cheese with watermelon, even though in some countries it's a delicacy. So protocols are a set of rules that you follow while using a set of objects that you need to communicate with each other. So they're just definitions of functions or values or variables. They do not do anything inside them. It's only the responsibility of the class or the structure that's using it to implement them. So let's go and start defining a protocol and see how actually we write a protocol. So I'm going to go and open Xcode and create a new playground. And call it protocols. Delete everything in here. So protocol is started with protocol, the name suggests. I'm going to give it a name, let's say recipe. So my protocol is a recipe protocol. Inside this, as I mentioned, I can create some variables. So I'm going to give a name to the recipe, make it of the type string. There's something wrong here that I'm not gonna let you know, and there you go. So property in protocol must have explicit get or get and set. So a protocol, when you're defining variables inside it, you probably have to give minimum a getter. I'm going to give a getter for this, so you can actually get the value of it, but you can't set the value of it. I'm going to give another one called as recipe description, set it as a string too, and this one give both get and set. That's it. And next, let's define one function, a basic function that says tell me about this recipe. Now I'm not going to give the implementation of this, just the functionality, and let's say this returns back a string. So if you see a protocol, I'm just defining the functions and variables. I'm not actually assigning anything to it. That's how far the protocol goes. You don't do anything away from it. So when 2 classes or 2 objects are talking to each other, they can implement this protocol in them, and just so that they can communicate through functions or to values, so they can talk to each other. So that's how. Protocol extension. So now we know how to create protocols. Next, if we want to provide some default functionality to protocols, we can extend the functionality by using extension. Also, sometimes I call it ready to eat recipes. Even though someone defined the recipe for you and you want someone else to follow it and provide it to you, that's ready to eat, or say extension. It's totally up to you if you want to use this extension or not. You can go ahead and create your own or just use this. So kind of a basic functionality. You can also override it with more functionalities that you want. We can see this in our example that we created. We just created a recipe protocol, and let's say if you want to, so if you see this, we didn't give any functionality to our function, but if you want to give like a base functionality to it, so if someone who's implementing this recipe needs to just print it out, something like that, so what I can do is I can just say extension. What am I extending? The recipe. And I am going to extend this function. So I'm giving a basic functionality to it. Inside this, I just, let's say, return the name of the recipe and the description of the recipe. So if you see here, I'm just giving a basic functionality or extending the protocol just so that it gives some kind of functionality to whoever is using it. If they want to override it and write their own, it's up to them, whoever is using it, but I kind of give a basic function, and that's what an extension is. Extension helps you write some base functionality to your protocol. So we created some protocols, and we also created one basic extension to a particular protocol. Now next is, how do you use this protocol? So let's start with, let's see how we can use protocols in structs. So that's what we'll do. Let's use whatever we have created previously in a struct and see how we can bring everything together. So I'm going to go back to our project that we created here, recipe and extension recipe that we created. Next, I'm going to create a structure, and I'm going to call this structure a dinner structure. Now in this particular dinner structure, if I want to use a particular recipe, which is this protocol, and just do this recipe. That's how you implement a particular protocol inside a struct. Now it says that there's some problem with it, because if it follows, if you see here, type dinner does not conform to the protocol. So you're saying that this guy is saying that dinner is not actually following recipe. So I can just go here and I say fix this, and if you see, it will create the variable name and description for me. Now since this functionality is available by the extension, you don't have to implement it, and you can directly go ahead and let's see how it looks like. Variable, I'm gonna say create a dinner structure. I'm gonna get this, and I'm gonna provide some basic name. So let's say, let's try fried rice. Let's give it some description. What is a fried rice? Very good question. Now I say fried rice is a dish of cooked rice that has been, let's say, stir fried, hope so, in a wok or say frying pan. Something that I picked up from Wikipedia. You can say it whatever you want. You can add some ingredients to it if you want, such as eggs, vegetables, seafood, meat. It depends on who's eating it. Now next, I can just go ahead and say print dinner, no, not this, dinner dot, I want to call that function, tell me about this recipe. Even though I have not implemented that function here, you will see it prints it out because the extension provides that functionality, basic functionality to it. I can go ahead and take this functionality and override it in my structure. Say I love, let's say whatever it is, for dinner, which is this description, something like that. So if you see, as soon as I implemented this here, it kind of ignored this one. It says I love fried rice for dinner, which is, fried rice is a dish of, I mean, there's no need to go into details of this, but if you see, I kind of, when I implemented this function, it kind of overrode this, and you can have your own functionality. I can also get rid of this extension if I don't need, but if some other class or struct is using this, they can kind of use this basic terminology for it, and then if they want to override it, they are free to override it in this particular manner. So that's a little bit about protocols and how to use it and how to implement it. I hope it kind of helps you. Thanks. Swift generics. Swift provides generic features to write flexible and reusable types of functions. Generics are used to avoid duplicate implementation and also better abstraction. All the Swift standard libraries are built with generics code. Arrays and dictionaries that we used before, these types belong to generic collections where arrays and dictionaries are defined to hold any type of values, be it int, double, string, or any kind of custom object, anything. Let's say in cooking, it's more like a process you follow but with different recipes. For example, you don't need a new kitchen to cook a different recipe. The same kitchen you work in can be used to cook anything, breakfast, lunch, or dinner. Think how difficult it would be if you have to use a new kitchen every time you have to cook something. And that's what we been used to do before generics came along. So that's what we used to do, which is bad. And now with generics, it helps us reduce that kind of functionality. So we write the function once and use it with any type. Let's look at some examples of how to create and use generics. So I'm going to start with the project in Xcode. Say new playground. Next, let's call it generics. Let's delete everything in here and start with the function to, let's say, swap some food. Now I can give an item 1. This is what we used to do before, so I'm not going to do anything that is more like generic version. I'll do it once. I'll show the bad version of it and then I'll show you the good version of it. So I'm going to give a string. So I'm going to kind of swap two items. Let's say item 1 with item 2, and item 2 is also a string. Now if I want to actually make sure that whatever is coming in is being modified, I can use inout. Inout means that modifying the local variable will also modify the passed in parameters. Without it, the passed in parameters will remain the same. So I'm going to change it here. So this is inout. Go. And inside here, let's just write a simple create a temp object, and I'll say this is item 1. Next I'm going to say item 1 equal to item 2, and next one item 2 equal to temp. Pretty straightforward swapping mechanism here. If I want to do this, I can let's pass some values to it. Let me create a variable. I'm going to call it first course equal to, let's use fried rice. Second course, I can say more like lentil soup. That's how I like it. But let's say some people don't like it that way and they want to swap it. For example, let's print this out and see how it looks like. I'm gonna say first course and make sure this is outside second course. So I have both my courses, if you see, but some people don't like it that way, so they want their soup before the rice. So I can just say the first course and the second course. The and sign here is more like you're passing the enter object, the reference type, so I'm not kind of giving a reference to that object, and there you go, it goes there. And if you see now, if I try to print this out, the first say fried rice and lentil, and then since it's swapped here, it's a lentil soup and fried rice. Now if I want to do the same thing for, let's say, something that is integer, so I can say function, let's give this name, I can say swap dinner and lunchtime. I don't know why I would want to do that, but let's say I do want a function that kind of takes in, I'm going to copy this here. Oops. I'm going to say time 1 and time 2. These are ints. Let's say whole numbers, not doubles or anything. I'm just using entire numbers here. We use something similar. The swap mechanism works the same way. So this is time 1, time 1 is swapped by time 2, and time 2 is temp. So looks fine. Now next is, let's give it some values, just what we did before. Lunch, let's say, is at noon, and dinner is at around 7 p.m. Let's say that. So lunch and dinner, let's print this out and see how it looks like. Lunchtime, dinner time. There you go, should show up lunch and dinner time. I want to swap it. Swap dinner and lunchtime. I'm gonna say swap lunch with dinner. Now when I print it, I'll have lunch and dinner swapped. So this is how it works. Now you have to write the function 2 times. Once for strings to swap and then ints to swap. Now instead of this, if there was one function that would do both of them, so that's where generics comes into picture. To give start generics, I'll probably say swap, let's say 2 items, and when you create generic, you have to provide these angular bracket, and inside this you provide t, which tells it that you're going to provide something in your arguments, which can be anything that you want, or can be any type. So here I'm going to say, so same functionality goes here, can insert this here, and instead of string I can say t and t. That's the value type that it takes. So it's not a string or an int or double. It can be anything that you provide here, and it will swap those 2 items. The values are pretty much same. So it will take item 1, temp, item 2, and it will swap these. Now I don't need this function. I can first course, second course, I'm going to say swap 2 items, and you'll see what happens here is, after note that I've commented out, it takes a few seconds. If you see, it worked perfectly. Now will this work for numbers? Let's try it. I'm going to comment this out, and I'm going to say swap 2 items. Item 1 is lunch and dinner, and after a few seconds you'll see it works. So you write one single function instead of 2 different functions, and it takes any type of values and it will swap it. So every time you're kind of writing the same type of logic for different data types, you can always use generics, which makes your life much more easier. That's it. Say hello in Swift. So now that we have learned Swift, whatever we did before using storyboard, let's do entirely in code. So what I mean is, instead of using storyboard and doing drag and drop for text fields, for labels, for buttons, let's do everything by code. It sounds pretty difficult since we are so much used to drag and drop, but this will help us learn Swift much better. And in real life you'll never be using that, but it's much more, it's a good idea to understand what's happening under the hood. So that's what we'll be starting with. We'll start a project. So I'm going to start an Xcode project, and I'm going to set it a single view application. Next, and I'm going to call it, let's say, hello app Swift. None, Vivian Runner, Swift. Next, let's start. Save this on my desktop and have my project ready. So usually what happens is, whenever I run my application, so from the second section that you learned, that if I run this application on my iPhone 8, it will install the application and run it, and this is what is on the main storyboard, is what you see there. So this is where we went and added some labels, drag and drop, something like that. But what actually happens is, whenever an application opens up or launches, it creates a window for each and every application. So every application has its own window. This one has its own window, this guy has its own window, and there's one window, and inside that you can have more than one view controllers. That's something that you saw when we used tab bar controller, navigation controller. In this case we have only one view controller, and that's this view controller. So what happens is, when app delegate launches, it creates a window, and inside that window it says, because of, let's close the utilities, because of this here main interface, it says main.storyboard is what I want. And that's why we see that from main storyboard it launches, what is the first view controller? This one. And what's the name of this view controller? Let's look here. It's view controller class, and that's why it picks up this view controller class and draws that particular view controller. So let's go back, and since we don't want to do this anymore, we don't want to load our, see, let's run this and see if this label shows up here. And then we have the label here. So what I'm going to do is I'm going to go ahead and delete this storyboard. I'm going to say move to trash, so it's completely gone away. Next, I'm going to go here to my launch screen so I can just see the difference between launch screen and the main storyboard. I'm going to add a label here, move it to the, let me make some space here, let's move it to the center of the screen. I'm going to call it Hello Swift, and go to the properties. I'm gonna center align it, make sure it's again in the center of the screen. Now when I run it, you will first see Hello Swift, and then it might crash because I removed the main storyboard. Hello Swift, and then it will crash your application because the main storyboard is not there. The thing that is linking it is right in the project properties. So I can go here, and I can say there is no main interface. So just click outside of it. Now what it will do is it will launch the launch screen and not do anything. It doesn't have a window anymore. So what we have to do is we'll have to create this window by hand. So this window that we created doesn't exist. So what I'm going to do is I'm going to go to this did finish launch with option. So as soon as the application launches, it calls this function. Who calls this function? We'll look at it when we do protocols and a little bit more complicated things in future. So this function is called automatically. So how do I create a window? So I have a window variable created. All I will do is I'll go and say window equal to, I want to create a UI window object. So I'm going to say UI window object, and I can give its frame. So frame is how much, where, so you can give a CG rect, which is where does it start, X coordinate, Y coordinate, what's the width of it, what's the length of it. So for this particular screen, I'm not going to use CG rect. What I'm going to do is instead of that, I'm going to say UI screen, the screen size, the main UI screen of this particular device, what are its bounds. So it's going to get its bounds. So if you see, this is of the type CG rect, so it can take this argument, and what it will do is it will take the screen size and make the window as big as the screen size. So that's the first step. Next, let's check if window is available. So I'm going to say if let window equal to window, the window is available. What I'm going to do is I'm going to set the background color of the window, because right now I see everything I see is black. So even if I create a window, it will be black by default. So I'm going to give a background color to this. I can say UI color, or I can directly say dot white. So it will be white in color, the background. Next, I want to make it visible for the user to see it. So I'm going to say window dot make key and visible. So this will be displayed on my device. So then let me run this and see what happens. First the launch screen will display, and then once that goes away, again we are crashing here. So the reason it's crashing here is it's saying that application windows need to have a root view controller. If you see this, and what we have done is we have created a window, but we have not given a view controller to it. In the previous project, we've seen that it automatically adds one. So what I'm going to do is I'm going to say window, and it has a property called as root view controller, and that I'm going to create, let's say UI view controller. So it initially creates a new UI view controller, attaches to it. Let's run it and see if it works. So it's installing the app, Hello Swift, and there you go, it displays. If you want to see, I can just create the background color as red just to see the difference from the previous one and this one. So see, so this is my launch screen, and that's my red screen. So just to make it more generic, I'm going to create it white. So that's how you can create it. How can I add more things to it? Let's try to add a label and see how we can add a label to our first view controller. So I created a view controller here. I don't need this view controller right now because I'm creating my own view controller using this UI view controller class. So inside this, I am going to say, so let me do this first. I'm going to say let my view controller equal to this view controller, UI view controller, and I'm going to pass this view controller to this Windows root view controller. Next, actually, I like to keep my code in a particular order. So I'm going to move this here, and here when I'm making my view controller, I'll add more things to it. So I'm going to say let me make a label. The way you make label is it's called UI label, and then something similar to before. I'm going to give a frame. Let's give CGRect this time. So I'm going to say CGRect, and it takes coordinates as I mentioned, x, y, width and height. So x is somewhere, let's say 100 pixels from the left or 100 points from the left. Y, I want 100 from top. Width, I want this to be, let's say from the, so I have to kind of calculate the width. Now what is the width? 100 on the left, 100 on the right. So what will the width of it? I can say something like window dot frame. So whatever Windows frame is, so entire frame from this end to this end, let's say it's 300. I can say dot size dot width. So that will give me the entire width. So if it's 300 and I'm already have x 100, I have to remove 200, so it's right in the center. So 100 from here, 100 from here. I removed it from the entire width. So that's what I've done. Height, I'm going to give it 50. So I have my label ready now. Once I have my label ready, let's do some more properties, like let's give it a text alignment. I'm going to say text alignment is center. So the label, whatever text is inside it, let me add some text. Text equal to welcome user. I'm going to say, and then I'll add this to my view controller dot view dot add subview. So I'm saying to my view controller's view, I want to add a subview, and that subview is my label. So I do this, should be attached to the view controller, then the view controller attached to the root view controller, then I see it. Let's run it and see if we can see our label being displayed. Just gonna install the app, and hello Swift, and next one is welcome user, which we have added. So to complete this project, let's see how we can, instead of using the code here, how we can add this code to the view controller. So all I have to do is give the name of the class view controller. That's it, and it will use that. Now it will not add all these things to it. So it will add them, but I don't want it to be added here. I want to add the items that belong to view controller in the view controller class. So I'm going to go to view controller, and inside this I see a function view did load. This is the first function that is called when the view is loading. So right here, add this. Instead of window here, because now I don't have a window, I'm going to say self.view. So this view controller has a view. I'm going to say to that add this. Even to this I can say self.view add subview label, because before it was view controller. Have all these parameters here. Let's see if it still works. Hello Swift, welcome user. I'm going to move this a little bit below. So instead of y being 100, I'm going to give y a little bit of padding from the top. Let's say somewhere around 300. I'm going to add a text field and bunch of other items that we have added before when we did this. So similar to label, I can say text field equal to UI text field. Same, I have to provide a frame to it. Frame is CGRect and X coordinate. I want it to be padded 10 from the left. Y should be, let's say, around 100. Width should be, again, same thing. I can say view dot frame dot size dot width, and I need 10 pixel in the left and 10 pixel in the left. So I'm going to remove those, right and left. Height equal to, let's say I give it 40. Next I'll say text field doesn't come with a border by default, so I'm going to give a border to it. Border style equal to dot rounded rect. So you can look at all these different parameters, what all different parameters there are: line, bezel, none, rounded, rect. I'm going to give that. Next, let me add a placeholder to my text field. Placeholder equal to enter your. So see the difference between drag and drop and writing everything yourself. It's a lot more tedious, but you get the idea of it. Self dot view dot add subview, and I want to add the text field to it. That's my name. That's here, text field added. Let me see, everything is good. So I have my text field. Let's run this and see if I have my text field. It should show up right on the top. around 100 padding from 100 pixel padding from the top, and there you go. Enter your name, shows my Xcode, displays my, now I need a button. So I'm going to create a button. I'm going to say let button equal to, again same thing, UI button. I give a frame to it. I say cg rect x is, so this one I'll make sure that the width of the button is 100, a little differently, and the height is, let's say, 40. Y is should be below it, so 100 is the starting point of this guy, and this is 40 pixels, so 140 is taken. So I'm going to just move it a little bit below, and 200. Now what is the x coordinate? What is the starting of this button? So since I'm taking 100, so that means I have view dot frame dot size dot width, entire thing, minus 100 on the left, on the right, so it should be divide by 2 minus 50, because the width is 100, so divide by 2. So divide by 2 will bring my point right here, and since the button size is 100, half of that is 50, so that button will start here. So that's how you calculate this. So I'm a button, I'm going to add it first thing directly to my view. So I've added that. Next, let's give it a, if you want to give it a title color, set title color. What color do you want? By default it's white, so I'm gonna, since the background is white, I'm going to say I want the blue color. And UI control state, and I'm gonna set that normal state. So there are a bunch of different states, highlighted, selected, normal. So I'm going to set that. I'm going to say button and set a title for it. Set title is click me. Control state normal again. Next I will, so I have this button, I have the color for the tint. Next thing that I can do is I can set background color for this, but I'll leave it to you, whatever you guys want to do. So I have my text field, I have my button, I have my label. Let's see all of them, all three of them in action. So my label, button, and my text. Now when I click on this, I want something to happen. So what I have to do is I have to add that action which we added from drag and drop last time. In this you say add target, and who is going to correspond to this the view controller. So before, if you know the view, whenever something happens with view, because of the model view controller design pattern, it's asking who is going to take, who's the controller. So I'm going to say self, this particular class is the controller. Action, and I have to set a selector, and this is how you set a selector, which means the function selector, and I'm going to call it button click. For control events, touch up, same thing that we did when we did drag and drop, touch up inside. That means someone clicks inside this button, what should happen? This function should be called. Go here and I say function button click. Now it will give me a warning here, since I'm calling this function from here. It's more of Objective-C function, so I'll have to specify @Objective-C function. So that will take away the error. What do I want to do? I want to take the text from the text field and display it in the label. Now if you see, the label and the text field are defined inside this, so I can't access this outside. So what I'm going to do is I'm going to take this text field and define it outside, call it variable, because I'm going to initialize it, UI text field. Do the same thing with my label, say variable label, UI label. So I have both of them, so I don't have to define them here. So that changed from let to var, because let just makes it a constant. Now I'm initializing it, and then I'm again changing its frame, so that's why I changed it from let to var. So it's a variable. I have that. Now next I'm going to do is I'm going to say label dot text, or just text, equal to text field dot text. So if you see here, text for this is optional. So what will happen in this case? Let's run it and see. Let's run the project. It's installing. Once it opens up, it says welcome user, which is the default set. Let's say Vivian click me, and it says Vivian. So it took that value and displayed it right over here. Now if I want to give a hello or welcome and use this value, now what we will do is, before it was both of them were optional, now you're kind of giving a string value. So when I enter my name here and say click me, it will say optional, and whatever is value inside that. So what I'll have to do is I can use like forced unwrapping. That's one way of doing it, to getting the value out, and it will work perfectly fine because we know that there is some kind of text. Either there is an empty string or there is something that I have entered, and it will display that. Now if I want to make sure that I don't use forced unwrapping, you can always do if let name equal to text field dot text, I can say label dot text equal to name, else, and there will be never a case when it will be nil, so you don't have to worry about this one, because there's always some text. Either there's an empty string or no string at all, so empty string or there's some value, so you'll never have to, this will never go inside the second else loop. But these are different ways of doing it. You can also use guard, which we learned before in Swift, of how to guard your variables. You can click something here and it works that way. If I remove this and click me, it will say welcome, so it will not use an empty string in this case. So that's our first application. We will do a couple more from our first 6 projects. I'll probably do the segmented control, and then we'll do the World Wide Web examples that we did, and then we'll look at tab bars and navigation. So that's it. This is how you can code everything from hand without using the drag and drop interface and build your application. So it's a lot more tedious, but you get to get an idea of how does it do it and how much time it will save you when you use drag and drop. Segments of Swift Life. So we created something like segments of life in one of the previous section, where we just use drag and drop or storyboard to drop in a segmented controller and label, and it worked pretty fine. Now how do we do that without a storyboard, just using code? So this is another one of those projects that we did before, where we had a text field button and a label, and we said hello world. So let's try the same thing with the segments of life. I'm going to start with a new project. I'm going to call it segments life and keep everything same, and save my project, my desktop. If you remember, we created this project which was completely in code, and we can enter your name, click button, and have the name display here. So similarly, what we are going to do right now is we're going to go back here. The first step, remove this main. You don't want this. If you have this, it will give you an error. Go and delete this file, move to trash. Next, I'm going to go to view controller. I'm going to keep my view controller. Inside app delegate, if you remember, now when the app launches, there's no window available. So what I'm going to do is I'm going to go here in did finish launch with option, and we'll learn more why we do this here in lifecycle in the next section. But for now, let's go and create that window, which before the storyboard was creating it. So I'm going to say frame. I'm going to say UI screen dot. So the main screen, whatever your bounds are, I want that's the screen for my window. Next, I'm going to say if, let's say, if the window exists, if it was successfully created, what I'm going to do is I'm going to set the window, same thing as before, dot background color equal to UI color, or I can just say dot white. This is something good with Swift 4. Before you had to set the entire thing. I'm going to set another thing, the view controller. My view controller equal to, I'm going to use the view controller that is already been created for me. I'm going to use that, and then next I'm going to say window dot root view controller equals to my view controller that I just created above. And last but not the least, this is the most important step that shows the window. So I'm done with that. I have my view controller. That's what it needs. That's the basic thing that you need, or else it will crash, which we saw in the last project. I'm gonna make sure that I'm not using a iPhone 8 Plus. I'm just gonna use my iPhone 8. Run this project. It's gonna install that application, and I have that application running here. Next, what I'm gonna do is I'm going to go into my view controller where we write all the code for the segmented controller. So first thing that we need is, let's go on the top, and before my view controller is loaded, or before this code, I'm gonna say segmented control equal to UI segmented control. I'm gonna blank initialize it so it's there, and it's okay. There you go, the error is gone away. Create a label too, just so that I have a label to display when user changes the segmented control. Now when the view loads, what I'm going to do is, again, this view load, we're going to look at these things when we are doing the next section on the life cycles. So for now I'm going to say segmented control equal to UI segmented control. I can select my frame, or I can give items. Let's give items. So these items is an array of items of what item do I want to display on the segmented controller. I'm going to use my basic food example, breakfast. Let's say lunch and dinner, 3 items. Okay, close this, and now my segmented control with 3 segments is available. I'm going to go at the end, and I'm going to say view dot add subview, add the segmented control to it. So segmented control gets attached to that. Have to give a frame. Since I didn't initialize it with the frame, I'm going to say frame is, let's say CG rect, and based on my previous numbers, I'm going to give something similar. I'm going to say x is 10, y 100, width I can say based on self dot view dot frame dot size dot width minus 20, 10 for the left, 10 for the right, and height I'll give it 40. Now I have my segmented control. I can say I can add a target just like how I added to a button, but let's see how it looks like just without adding anything else. So when I run this application, we'll install the application, it's open, and we'll see 3 items over there. Nothing is selected. You can select one by saying segmented control dot selected segment index equal to 0, 1 or 2. 0 is the breakfast, 1 is the lunch, and 2 is dinner. So let's select breakfast, and there you go, that's selected. So I can have that selected, but I'm going to leave it unselected. I'll let the user select what they want. And the last one, segmented control dot add target. So what should happen when the user clicks on that? Who is going to respond to this? This view controller action. We did this in the last one. I'm going to say selector, and the selector is segment change. That's what I'm going to call it. For control events, if you remember, we selected value changed when we did drag and drop. I can do the same thing here, value change. So whenever value of this segmented control changes, it should fire this function. So I've not created that function yet, so that's why it's giving me a problem. I'm going to say @Objective-C function name, and there you go, we have that. Next, let's create the label too, UI label. Again, I'm gonna initialize it with frame, CG rect, and x. There you go, that's my function. I'm gonna give 10, let's say 200, a little bit more than previous one, and I'm gonna copy paste the same things for this. You can be that 40. So I have my label available. Also make sure the text is aligned properly. Text aligned equal to dot center, and next one is label dot, let's give some placeholder text. I'm gonna call it select 1 because nothing is selected in the start. I'm going to say select 1, and whenever they select, the value will change. I'm going to self dot view dot add subview, and I'm going to say label, and I have my label added. Now here, when something is selected, instead of using if else, else if, I'm going to say switch statement, and depending on segmented control dot selected segment index. Which one is selected? I'm gonna say 0. If the first one is selected, I'm gonna say label dot text equal to most important meal, and I'm gonna copy this couple of times. So 1 and 2. I'm gonna say lunchtime, yay, something like that. And dinner, let's keep it light. Let's say that, and maybe one more just for default. If none of them is selected or something weird happens, I'm gonna say select 1. Okay, so I've set up everything looks fine. Let's run it and see if we have or we are on track for a segmented control. Just gonna install the application, run it. Nothing should be selected. Just say select 1, lunchtime, let's keep it. So that's how you can code the entire thing without needing the storyboard for a segmented controller. Let's look at next one, the web one, and you can try to do the other. So we did 3, we have total 6, so I did 3 of them. You can try the other 3 ones. So let me do the web view, and then you guys can follow along and then make the other 3, or if you have questions, let me know. Worldwide Swift web. So instead of saying World Wide Web, I just added Swift in there, just so we can do whatever we did in our worldwide web project in the previous section, where we just used a WebKit framework. We kind of dragged and dropped a WebKit element or a web view element. Web view is a kind of deprecated, and now we're using something similar for that. It's called WK web view there, but before we used to use the web view. So if I use that word by mistake, I'm kind of used to that, so that's something very common. Anyway, so let's use WK web view and see how we can something similar. So I have a project already in the making. I'm gonna say web view world. Next, create the project, and inside my, let's see, first step, delete this, move to trash, go here, get rid of this, make sure it's not there, save the files. And inside my app delegate, since I don't have a window, I copied this code from the previous part. Also, what you can do is, if you're kind of reusing this code again and again, what you can do is you can go to your code snippets, and there's a bunch of code snippets that are given to you by Apple itself. But if you want to use your own, what you can do is you can kind of select the code, and then you'll have to be in a particular way where it comes. You can drag it. So I'm trying to get hold of the code and add it right here, and it will have the code here, and it'll say what code is it. I'm gonna say window code. It's gonna say users generated. So next time if you're doing something like this, what you can do is you can just drag and drop it, and you have the code there. So this is a quite improvement, or you can say you can write your components or something that you think you will be using quite a lot. You can add it over here. But other ways also, you can create a library for that, which we'll see in one of the future sections. So I have my window created. I will check if window is there, view controller, and everything goes to the view controller. Now inside view controller, first of all, since the web view or WK web view is not part of UI kit, I'm gonna say WebKit import. So I'm gonna importing the WebKit. Next, let's create an instance of, I'm gonna call it my web view, and initialize it with WK web view. Okay, so I have my WK web view. Next, I'm going to initialize it here, my web view, okay, equal to WK web view, initialize it with a frame. Now for the frame, what I'm going to do is I'm going to start X with 0 from the very end. I'm going to fill the entire thing. Y to 20 because I want to take care of the status bar on the top. Width should be self dot view dot frame dot size dot width, and for the height, use the height, and I have to remember that I have made it 20 from above, so I'll have to reduce the 20 from the bottom, from the entire height of the screen. So that's done. Next, self dot view dot add subview, and I need to add my web view to it. So this will add the web view to the thing. But what if I want to open a web page? Let's say I want to open Apple's website as soon as the web view loads. So I'm going to create a URL, and this URL takes a string, and that string is https. I'm going to remove this, www.apple.com. So I have my URL ready. Using this URL, what I'm going to do is I'm going to create a URL request. What happens is whenever you create a string URL, convert into URL, then you have to make a URL request, and you have to ask the web view to make that request to your server. So that's how server client works. We are building a client, and this client is going to make a URL request to the server. So it's your internet provider you're going to request to. So I'm going to create a request, and this request comes with a URL, and that URL is this URL. And last one, I'm going to say my web view dot load, and the request, do I have a request? Yes, I do. I'm going to pass this here, thing like this. I have the entire thing. The problem with here is this URL might be an optional. What if there is no, where's the value is nil? So what I'm going to do is I'm going to say that since I'm kind of initializing it here, or you can use guard or iflet for this, but I'm just going to keep it this way. Run the application. Guess I've done all the things that is needed, or else it will crash. So let's look at it. So first it's going to compile the application, make it into an app format, which is this product here, install the application. Okay, I selected iPhone 8. I'm gonna go back and select iPhone 8, run it again, and it installs, and I have my application running here. Where is the website? You give it a couple of seconds. I think my internet is running a little slow, and it will launch. And even anyway, first time it's always a little bit slower. So there you go, we have our WebKit running. It's Apple's website. It's up and ready for you to use. So that's how you can actually have your WebKit kind of programmed using just code in Swift. So this is all the projects that we will do for application for different controls. In future, we'll just use the shortcut and use the storyboards to do it, since Apple has provided such a good feature. I just wanted to show you what happens in the background and how you can, even if you want to just write code, you can still do it. I know there are some people who just like to write code and make applications, so that's possible too. It takes a little bit more time. Sometimes, long back I used to like doing that, but since storyboards came out, before there were interface builder, which was not that helpful, but since storyboards came out, it's much more easier to design your entire flow and then go ahead and write whatever minimal code is required for that particular purpose. Swift tab bars. So we created tab bars before. We created 3 different tab bars in the previous section, which we gave red, green and blue colors. Now we can do the same thing using code here, but we need 3 different view controllers. So let's go ahead and start with a single view application. I'm going to call it tabs in Swift. We completely code, and I have 2 images that I've added for the tab bars. So I have these 2 images. I can drag and drop these images here, which I'll be using for the tab images. And so I'm going to create 2 tabs this time instead of 3. And I'm going to delete this storyboard because I don't want that to be involved. Get rid of this, gone, and then go back to my view controller and app delegate first. So this is the first thing that gets called. We also created our window code here, but a window code will change a little bit different. I think I forgot to add the window first, so I'm gonna add UI window. Oh sorry, I have my window here. Window equal to UI window frame cg rect, and or frame is UI screen dot main dot bounds. So I have my window, and then I check if the window is there. If I don't add this code, it will skip this because there is no window available. It's not created by storyboard and nobody creates it. And this is what we did before. What I'm going to do is I have one view controller, the other one I'm just going to use UI view controller. So I have my first view controller. I'm going to create one more. Call this one first. I will call this one second, and for this one I will use UI view controller. This view controller, I can go here and I can give a background color, say view dot background color dot red. I'm going to do that. And for the second view controller, since it's programmatically created and not as a separate file, I can always say second view controller dot view dot background color equal to dot green. I'm just going to use two of them, so red and green. So I have that options available. Next, it's giving me error here because I don't have the tab bar controller. So as soon as I'm done with this, I'm going to select my view controller equal to UI tab bar. It's not the tab bar because tab bar is just the tab bar. I want the tab bar controller. Create the tab bar controller. Next, I'm going to say my view controller, this is my tab bar controller, and I'm going to say this will have view controllers. So if you look at this, this is an array of view controllers. So I'll have to give it array of view controllers. I have two view controllers, first and second. I'm going to give these view controllers to this guy. So it's very simple. I created a first view controller, created a second, I added the UI tab bar controller, and I took that view controller tab bar controller and added to the window. So the window has the tab bar controller, the tab bar controller has the first view controller and second view controller. Does it work? Let's run it and see if we removed everything that we have to, and should show me tab bar. You'll see something weird here. Let me just actually close this again and go back to 8. I have my application being installed right now. I will see a tab bar at the bottom. And there you go, my tab bar is there. I see red color. I know the first one I gave red, but I don't see any tabs. If I click here, nothing happens, but if I click on the right side and left again, so there are tabs, but I don't see anything happening over there. So what I'm going to do is I'm going back to my first view controller, and I'm going to say first view controller, I want a tab bar item, and the title of that tab bar item should be first. Similarly, I can say first view controller dot tab bar item dot image that I want. I have two images here. The first one ANKH. I can't use it directly, since if you see this takes a UI image. So I'm going to say UI image named, and what is the name of the image? This is where I pass the image ANKH dot PNG. That's how it works. Same thing I'll do for my second view controller, just that it's a different name, and this becomes circle. So run this again and see if you see the tabs come up. So there is tab bar item, but we didn't give any title or any image, so that's why it was blank. So when I do this, if you see, I have my, and since I'm using glyph icons, these are grayscale images that I've created and I've downloaded from somewhere, and if you see this, it kind of turns blue automatically. Even though the images are not blue in color, they kind of highlight because they're grayscale, so it kind of takes their grayscale and converts that into blue. So it's automatic that you'll get that kind of behavior. So I have this tab bar. So this is how you can create tab bars with App Delegate with just Swift code in there. You can add as many as you want. You just keep on appending to this array whatever you want. I can keep on adding, just say UI view controller, and it will create one more because that's an instance without a name. It doesn't have a name. It will just create a third one and have that display up there. So I have, but just that I didn't give any image, it will not have anything. It is just a basic without anything view control. So you can keep on adding, play with this, and let me know if you guys have any questions. Swift navigation bar. So I'm going to create navigation bar functionality that we created in the previous section, but this time without any storyboards, just basic Swift and code. So that's how we'll build it. Again, I'm going to start with the single view application. I'm going to call it navigation Swift. I'll save it in my projects, and then go to App Delegate. First delete view the main storyboard, go to the project, delete this, go to my App Delegate, and I have window, but I'll have to create that window. I'll take my snippet code, which generates the window for me, and I'm going to take my window and make sure I initialize it. UI window frame UI screen dot main dot bounce. After you do it a couple of times, it will be much more easier and faster to do this. Now in this case, I have a view controller that it opens up. This view controller doesn't have anything. I'm going to just to know that we are using this view controller, I'm going to say self dot view dot background color equal to dot red. So I'm a red background view controller. In here, it's going to launch that view controller for me. Select iPhone 8, run this application. Adjust the view controller that is added to the window, which is red. Now I want to add a navigation controller to my root view controller, not the view controller. So what I'm going to do is, after my view controller initialized, I'm going to say let my nav controller equal to UI navigation controller, and it has a function called as root view controller. So navigation controller, unlike tab bar controller, which can have many view controllers, navigation controller can have only one view controller, which for us it is this one. And I'm going to take this navigation controller and make it the root view controller of the window. So the window contains the navigation controller contains the view controller that we have created, which is this one. Now when I run this, it will show me a navigation bar and the view controller inside it. Install the app, opens, and the navigation bar will show up here. There's no title on this. By default, navigation controller will take the title of the view controller it contains. So I'm going to call it first, run it. And it will install and launch with that first title on the top. So now what I want to do is I want to go from first to second. So I can do that by going to first view controller. I don't have any more, so just for last time we used the view controller, this time I'm going to say new file. This is how we create a new file, Coco touch class. We call it second view controller. So of the subclass of view controller, Swift, next, create that project file. So I have one more view controller now. So from the first view controller, I want to go to the second one. So I can add a button here inside my code, and then add the code. When I click the button, it goes to a different function. Another way of doing it is I can also say self dot navigation item dot right bar button item. So inside the navigation, there's right side and left side. So I'm saying on the right, I want a UI bar button item. Just hide this, and it should have, what style do I want? So it has a bunch of different bar button style system item. So I can say that okay, this is the default one, I picked the wrong one. So I can say bar button item, what type of bar button I want. So I can say I want let me just redo this. Okay, bar button item. So bar button system item, do I want to use one of the system items that are available, or I want to create a custom one that I can add anything to it? So I'm going to create a custom one. I say title for this bar button item is second. Style, I'm going to use, there are two types, done or plain. So done is a little bit more capitalized than plain, so I'm going to use done. Target self, where is the function that will be called when this is called, and then again selector, just like any other button. Selector, I'm going to say go to second. So I have my right bar button available. Now the only problem that is missing is go to second function. I'm going to go here and I'm going to say go to second function. Of course, go for it. It should give me a warning since it's not an Objective-C, so it's going to ask me to convert that with Objective-C, and there you go, we have the function available. What I want to do is I want to go to the next view controller, so which is my second view controller. Initialize it first, second view controller. So I have my second view controller created. I'm going to say my second view controller dot title equal to second. So just like this first ones was first, and then I can say self.show. It's asking me which view controller do you want to show. So this is a function that is available. I already created one. Say this sender, who's the sender. I'm just going to keep that nil for now. Now what this will do is it will open up the second view controller and display it. Just so that I can see more details, I can do something like this: background color equal to green. You can try with one more, second and third, and have red, green and blue, but for this project itself I'm just going to show you this to write some repetitive code. So if you see here, this is the first, this is my bar button item. If I click on this, it opens the second one, and the left bar button item is automatically added. So in navigation controller, if you navigate from point A to point B, it knows where the point A is and will automatically give you the direction to go to point A. So that's what a navigation controller does. So you can have a bunch of different navigation view controllers, one after another, and then come back. Even though it's not good practice, I would always recommend have 3 levels of navigation, but if you have to, you have to. So that's how navigation controller works, and this is how you can add it through code. So I'd say try to practice this quite a lot, create few more, make sure that you create the first view controller and add like the say hello project, second one with a switch, third one with a segment, and go 6 levels down, have each and every controller available in your navigation. Do the same thing for tab bars, because more you practice, better your coding will be. Lifecycle of an iOS application. So we saw a lot of different functions that were available in your code inside app delegate when we were building projects. And at the same time, I'm not sure how the application runs or how those commands are even called and what are the different stages a application has. So if you compare it to your cooking life cycle, what you do is initially when you start cooking, you look for a recipe, then you follow some steps 1, 2, 3, and then that's the life cycle of your cooking from starting to or inception to eating time. So let's look at our application that we have. This is a basic application that I created, single application. You have all these different functions. The only function that we use till now is did finish launching with options. So what happens is as soon as the application launches, this is the first function that it calls. How does it know that this is the function that has to be called? Because of this UI application delegate, any class that follows this delegate. And we're going to look at delegates and protocols in more detail in future sections, but right now I'm just going to give you a brief introduction to that. You can read some of the documentation here, but whichever class actually follows this need to implement these methods. And whenever the application launches, it's going to call this app first. Then there's application will design active. There's a lot of text here below it, you can read about it, but I'm just going to give you a short version of it. Application will design active is called when, let's say, application is going into background or about to go into background. Application did enter background, this means it's in the background. Will enter foreground, it's coming back from the background and is in the foreground now. In between that, and as soon as the application is available for user to play with it, it will call application did become active. Also, there is application will terminate. So just before the application is being killed, or as the user is killing the application, it will call this function just so that you can do some memory cleanup, save some states. So that's why these functions are available here. We have only used this till now, did finish launching with options, but we can look at different states or something that they call as states of iOS app. So there are 5 different states. First one is not running. Then there is inactive, then there's active, background, and suspended. So this comes straight from Apple documentation. Not running is when the application is not running at all, either is terminated or never been used by the user. Then there's inactive. This is usually just when the user clicks on the application and it's about to come active. That's when the app is in this particular stage, inactive. It can also be while it's active and it's going into background, it will be in inactive state. And after background stage, so background stage is when it's sitting idle. It has a few seconds to do some things if the app has to, but the background functionality is disabled, the app doesn't do anything. So if you have some app sitting in the background, you know that they're not doing anything unless they have some special features like maps playing music. Pandora or Spotify, they play music in the background. You have maps app which constantly navigates you. Then there is a suspended state. This is where the application is sitting in the background and not doing anything. and after some time it will be in not running state until the user clicks on the button and it comes back to life. So this is the actual different flow of the application, or how it goes through from being not running to back into not running. So you can click on the application, it launches, becomes active. When you click on, let's say you get a call or something else happens, if you get a call, it goes in inactive, doesn't go in the background, and as soon as the call is over, it comes back into active. Again, if you click on some other app, it goes into inactive, goes into background. After some time, it will go into suspended state and eventually not running state. So these are different states, and the functions that help you get through these states are will finish launching with option. That means it's gonna launch, but it's not launched yet. Did finish, this means it's launched now. Did become active, it's available for you to do things right now, and you can write your code in there. Will resign active, it's going to go from active to inactive state. Did enter background, it is in the background state now. Will enter foreground, it's coming back into foreground state from background. Will terminate, that means the app is going from background state to suspended and eventually to not running. So these are the different states or life cycle of an iOS application. And you can write your code inside here. You can write some, let's say, print statements. I usually like to take the function name, write it there. Okay. Similarly here, print, gonna copy this, actually no semicolons, still used to semicolons since I'm doing Android programming in Java too, so it's a little difficult to get used to it, but more and more you code, and then you forget to code in other programming languages where you try not to put semicolon and it gives you an error. It's always challenging. So I run this application. I'm going to stop this and make sure it runs on iPhone 8 because I have my iPhone 8 simulator already running. And if you look in the debug side of it, just open the entire debug side. It said did finish launching with options, application did become active. If I click on the home button, go will resign active, did enter background. Click on it again, comes will enter foreground, did become active. So this is how you can see how the application goes into different states and follows the life cycle of the application. Life cycle of a view controller. We saw in the previous lesson what is the life cycle of an application, but inside the application there is also something called as view controller, and we saw that you can have one view controller or you have multiple view controllers depending on what type of or what your framework looks like or what your actual app look like. If this is a single view application, there's a single view, one single view controller. If you have a tab bar controller with multiple view controllers, they have each one of them has their own life cycle. Same thing for navigation, as in when you move from one view controller to another, you have bunch of view controller that gets created and destroyed as in when you go back. Like in navigation bar, when you go from first view controller to second, first is there, then the second. If you go to third, there's a third view controller. If you go back to the second, the third one is completely destroyed and you are on the second one, from second to first. The life cycle of a view controller is pretty much follows these different steps. There is view did load, where the view loads into the memory. It doesn't appear to the user, but it's loading into the memory. So if you want to do anything while it's loading in the memory, you can do that. View will appear. This is when view is about to be displayed to the user, but it's not yet there. Then there's view did appear, when the user actually sees the view and you want to start some animations or something like that, you can actually run that code here. View will disappear when the application closes or when you go from one to another. That's when view will disappear comes up. And then view did disappear, that means it's completely gone from the user's view or completely removed from or disappeared. So if you see here, this is the diagram from Apple's view controller, from disappeared to appearing to appeared to disappearing. These are different methods that the particular view controller kind of goes through. And I can kind of use my application that we used before, and inside my view controller I can go here and you see that view did load is already there. I don't need did receive memory warning right now. I'm going to just keep this one, increase the width of it. This is view did load. The next one was view will appear, so I can create that one. and I can always call super, because you're saying that, so since you are inheriting, you created a view controller class and inherits from UI view controller, so that means this Apple's UI view controller class is doing quite a lot of things inside it which you want to do too. So that's why when you're overriding a particular function, that means you're taking over a particular, it will not call from this file, it will call it from your class file, and you want to make sure that whatever happens here gets done first, and then you do additional step after that. So same thing I'm going to use for view will appear. I'm going to make sure whatever happens in the parent happens first, and then we get called here. Next one is view did appear. Do the same thing, super view did appear animated view will disappear. That's the next one. I'm going to say super dot view will disappear, and the last one for that, okay, the last one, if view did disappear, per dot view did disappear animated. So I have that available. Now what I'm going to do is I'm going to add print statement just so I can know when they are called. So I'm going to say print and view did load, add this inside my brackets, again print, do this a bunch of times and copy paste this so I know when they are called. Okay, this one is already there. Run this application, it launches the application. You can go here and see which, so view did load, view will appear, view did appear. If I click this button back again, it's not actually going away because the view is still there, it's loaded. Unless I go to another view controller or something happens to that view controller, it's not going to get called. Now it's going to just stop because I killed the application and the application is here. So if I go from one to another, it will call the other applications, but other than that, it will not kind of call the application. So this happens for each and every, even for these applications that are there which are built by Apple, they follow the same kind of technique. So that's how the life cycle of a view controller works. Debugging of iOS apps. So before we even do some more coding, let's look at how to debug our applications. This is one of the important topic because you'll have problems in your app all the time. Even though you follow step by step, you might see some issues or some problems that happen in your application and you need to debug that. Debugging is more of a term where it says debug, which you mean that there is a problem in your code, which means there's a bug in your code and you're trying to remove it, so you're debugging the code. So that's what it means. So I'll show you how to use breakpoints, and that will help you start up with some of the issues that you're already facing or some of the issues that you'll face in future, and you can kind of debug your application and get over with that. And as and when we do more and more of coding, I'll show you more different tips and tricks, but for now let's look at some of the basic breakpoints in debugging of iOS apps. So I made a simple application, it doesn't have anything, just empty. So what I'm going to do is I'm going to go in view controller, and as we learned from the life cycle that view did load is called first. So but is it called first? I can always click next to the line number here and put a breakpoint. This is a breakpoint. You can look at all your breakpoints that you've added through this breakpoint window. Can add as many as I want. This will never be called because we never have that issue. I can go to app delegate. As I said, this is the first one that is called. I can add a breakpoint here, and when I run the application, as soon as it hits a breakpoint, it will stop processing right there. So it opens up, it opened the launch screen. As soon as it finished launching with options, it just stopped here. Since it's a comment, it will never stop on a comment. It stopped at the next line. So it stops here and it says, what are you trying to look for? Are you trying to do something here? If not, you see here there's a bunch of different options. I'm interested in this option. This is continue program execution. This means like, okay, I'm done looking at whatever I have to look at. Okay, I want to go next. You can kind of print out different things. Now in this particular function, what we have is we have launch options, which is nil, so I'm not going to able to show you anything, but we'll see something in the next part. There's application here. I can always go and print out application. PO application is what you type, and it gives you information about the application. Not much helpful here, but let's go here and see. On the left side we have a bunch of different options. You can dig through of all the different things that is available to you. I'm going to say continue. I have this here. Nothing happens in view controller 2, so I don't have anything, so I'm just gonna continue debugging. I'm gonna remove these breakpoints either from here, or you can go here and select and delete these breakpoints just by dragging them, and it's okay. It's not, oh, since I didn't stop the application, let me just remove this application. Okay, there you go. You can just press delete on them and they go away. So that's one way of doing it. Now I'm going to write some code here. I'm going to create a function, very simple, to add two numbers. Let's say function add two numbers, and I'm going to give a, which is an integer, as an input, and b, another input, integer, and they will return back an integer to me, which is the result or sum of two numbers. I'm going to say return a plus b, or I can make it a little bit more detailed, but I can just return a plus b in this case. I can always say int or let x equal to a, let y equal to b, and then let z equal to x plus y, and I want to say return z, so it will return back z back. Now let's call this function. I can say add two numbers 9 and 4, thing like this, and I can run this application. Nothing will happen in this case because I'm not printing it or not doing anything with it, so I'm just gonna say let result equal to this and say print result. Run this application again and open my debug space, and right now says there's an error. Let me just run this one more time. It's giving me an error here. Error is saying there is a problem here, okay, because I think I removed this. Let's fix that. So I guess when I removed the the breakpoint, I was trying to do something and it just moved the return true on the previous line. Go here and you see this result being 13. Now I'll say that what if this result is wrong, or if 9 plus 4, I am expecting 13, and you don't know anything about this function right now, someone else implemented, and it doesn't look like 13 to you, it looks 36. So what is the problem? You can always put breakpoint here. The first thing is to put the breakpoint where you are expecting the result and it's not giving you the result. You can run this application and it stops here. Now I can look at result. It will not give me any value here, so I can say okay, I can click on this one, which means step over, meaning just execute this one line. It will execute that one line and go to the next line. Now I can see results value, which is 36. So I know that something is happening wrong here. Let me run this application one more time. And now I'm going to put breakpoint in here, but I want to go inside this function. So what I can do is I can click this, the step into. What it does is it will step into this function. So when I do that, it will go inside here. It will take care of all the variables, and only where there's operation it will look at that. I say a is 9, which is right. Y or b is, let's move it on top, 4, or you can see it here, 9 and 4. That's good. Say okay, let's go over this operation. I'm gonna say a step over, so one line at a time. So z is 36, so there's something wrong happening on this line, and then I see okay, instead of add, it's multiply, so I'm gonna say plus, and when I do that, I can run this application. It will not, because it already kind of took care of the application and I changed the code, so I'll have to rerun the application. And now when I run it again, I can go step by step on top of it, step into the code. I can say okay, go next line, 9, 4 and 13. Everything looks good to me, and then I can just say either I can, when I say next, it will go to the next line here, or I can just say continue execution. So this is how you can debug your application. Look at the options. You can, as I mentioned, you can always go and look at individual methods which are not available here. For example, I can dig deep to look at some of the view controllers title, or I can just say po self dot title, and it will say nil because I have not set the title. I can say po self dot view dot background color. If I set the background color, it says there is a UI color available here, but it is not set, so it's optional value and is not set. It's probably because I have not set anything. So you can set all the different things and then look at that values on right here in the debug window. So this is how you can debug the basic amount of debug. You can do a lot of debug with memory and CPU and see if everything is working fine, and some of these things will check on the memory management, which is the next video. Memory management. This is one of the most important topic in iOS. Even though people don't talk about it, this is one of the most important topic. The reason being, as and when people are, or our customers are having more and more applications on their devices, there is a chance that memory will run out, because you're running Pandora at the same time, you're using Maps at the same time, you're playing something else, you're looking at different stocks, you're looking at your email. There's so many things happening in that tiny device. Even though it's more powerful than some of the computers, there tend to be some mistakes as a programmer that you should not do in your application to make sure your application never crashes. And one of the most important reason for memory breakage or memory issue is memory leak. So let's talk about memory leak. What is a memory leak? Now let me explain you in simple words, and then we'll go into this. Let's say you cook something today. You cooked let's say lentil soup, and then you had some extra. You took that lentil soup, kept it in your fridge, and you made some other stuff, and then you kept that in the fridge, and slowly that lentil soup was pushed in the back of the fridge at the bottom shelf. Happens all the time, I know it. And then you forget about that part. You forget that there is a lentil soup bowl at the end of, and you can't see it because your fridge is stacked with so many items, and you keep on stacking your fridge with more and more items, and you always forget about that lentil soup which is sitting in the back of your fridge. So that's a memory leak, meaning there is a part of your, or a space in your fridge which is not being used. Why? Because it's being used by that stale lentil soup that you made 2 weeks back. So that's what memory leak actually is. So what happens is, when you create an object, it points to a memory location, and that's where the object actually sits. Whatever you create, let's say you say let x equal to something, that is a pointer to that particular object. So if you make a class object, the object is sitting at a place, and you have a pointer to that particular place. Now when you are done with that pointer, let's say you get rid of that pointer, I mean you just keep on going with other code, and you forget to release that object, and it's sitting over there forever. So memory allocated but not released, that's what memory leak is. Again, cannot be allocated again. That memory is just being wasted, no longer needed by the application. It's not needed, but it's still there. Reference has been lost. You forgot about that, or your code forgot about that object, and it's still there, and it can't be used by anyone. So that, and as and when you do more and more of these, eventually your fridge or your memory will explode because there is no memory left, and that will cause crashes in the application. So let's look at some applications and see how we can avoid this. So here is my simple application that I've created. It's very difficult to kind of create memory leaks in our current applications. We're using Swift and all these advanced programming because they take care of them, or something called as ARC, automatic reference counting. You can go here and look at your build settings and type ARC. So ARC, and right here you'll see Objective-C automatic reference counting, yes, which means it's automatically counting your memory and making sure anything that is not used, it will get rid of it. So let's go back and try to create a class. I could create a class separately, but let me create a class here. I'm going to get rid of this so that we can see the entire class in one single page. I'm going to get rid of my comments, just have this, just have pure code. Create class and call this class food. Okay, and inside this I'm going to create a variable called as name, which can be assigned by someone. I'm going to keep it the second variable that I want to make is eat with. So what do you eat this food with? Another food. That's what I'm gonna say, and I'm gonna create initialize. The reason I have to create initialize is because I have said that name is required, and I'm gonna say name string. Since my eat with is optional, I don't have to initialize that. Again, same thing with name. If I do that with that, but I want to have one single item which is required for this particular class, I will create name. Next, I'm going to print and say self dot name is allocated. So this is when that memory is allocated for this particular name, because it's created here. I'm going to also say d init, and inside my d init I'm going to copy paste the same thing, but I'm going to say released. So I have created my object, I've created my d init. So let's see what happens with the memory when I run this application. So if I create the object here, what will happen is it will be there as long as the view controller is available. So the memory will not be automatically be released when the view controller is destroyed. So what I'm going to do is I'm going to create an object here. So here let's say rice equal to food, and I'm going to say name is rice. So initialize one object. So this object is just used inside this view did load. So let's run this and see what happens. It's going to say initialize the object but never used it, but that's fine. So if you see what happens in the debug area, rice is allocated. It's allocated here. When it reaches the end of view did load, it's going to be released. I can put a print statement here and say view did load complete. So now when it creates the object, it's going to be created, then it calls view did complete, and the end of function shows up, and then it will be released, because the Swift is smart enough, or the compiler is smart enough to know that it's done with this particular function. So whatever is inside this, we can release it. You can click on this object and see all the different memory representation of that particular objects, of all the different objects are there. If you see an exclamation mark, that means there is a memory leak available. The only way to make a memory leak is through something called as a retain cycle. Retain cycle is somewhere where you have one object which is pointing to the second object, and the second object is pointing to the third object, and third object is pointing to the first object, which means, like, let's say let's say there are three different things: rice, then there is beans, and then there's salad, and all of them depend on each other. Think about it as if you're holding someone else's hand, and that someone else is holding someone else's hand, and that third person is holding your hand. So you can't get out of that cycle because everyone is dependent on each other. So let me show you an example. I'm going to create one more called as beans, which is a food, and name it beans. Create a third one, call it salad. So I create three items. Now I can say rice you can eat with beans. You can say beans you can eat with salad, and salad is something you can eat with rice. Okay, so I have all three items available here. Now when I run this, what will happen is, let's see what happens. Rice you can eat with beans. So if you see, my load is complete, but none of them are released. They are sitting in the memory and still waiting for you to explicitly release it, or some magic to happen. I can click on this here, and we will see some exclamation marks or some issues. So if you see here exclamation mark for food, it's saying that you created three objects with the class food, and they are dependent on each other, and you can't release them now. So you are kind of stuck here, and this memory is wasted. So think about, our food class objects are very tiny in nature because there's not much inside it. But think about if this happens with view controllers, where one view controller is dependent on another, or a big object is dependent on another, you're wasting a huge amount of space. So how do I take care of that? So whenever you have a retain cycle, what you have to do is you have to make sure one of them has a weak relationship with other. So in this case, we can set this guy eats with as weak. So what will happen is it will say that okay, rice is dependent on beans, beans is dependent on salad. That's what we've done here. You eat with this, eat with this, eat with this. But since when it will go to the last one and it will say, oh, I am creating a retain cycle or a reference cycle or a loop of dead, something like that for the application. So what it will do is it will see, okay, this relationship is weak, so I don't care if it doesn't exist. So it's going to just release that object and you will have no memory leaks. Let's look at that example. So I run that application. If you see rice, beans and salad, and when it reaches salad, it says, oh, it's done. Now salad doesn't depend, it has a weak reference with the rice, so we can get rid of it and they release salad, beans and rice. You can look at the memory allocation and you'll see that there is no problems, no issues with our code. You can see all the different things available here. You can debug them of what's happening, of where is going, is there any memory leaks, memory issues. Even if you take someone else's code and you run it, you can always do this memory management using this particular tool. So this is more of a continuation of the previous class and of debugging and then also memory management. So I guess you understand this. Make sure you don't have any memory leaks inside your application. It's very bad for you and for your customers who are using your applications. Delegates are nothing but protocols, or it's a name that is given by Apple to protocols just so that it makes more sense. Let's see what protocols are. Protocols are nothing but a set of rules that are defined by someone, and we're going to talk about protocols in the next videos. The reason I want to bring delegates up first is so you understand the basic functionality of it. So Apple has created a bunch of different delegates for us, or proper protocols for us, so we can use them with different things. The main reason or main purpose of delegates are so you can delegate some work to some other class, or you say that, you know, I am going to call these functions, whoever wants to listen to it can implement it and then use it. It can be optional and it can be required. Doesn't make any sense, but still, let's see how we can actually implement it so we understand it better. So I'm going to create a new application, call it delegates app, save it, and I'm going to make sure I use iPhone 8. So that preloaded, and nothing is inside this application. It's just the same empty view controller, nothing added to it. So what I'm going to do is I'm going to start with very common thing that we use quite a lot, or our first application that we built, which was say hello, where we used a text field. So I'm going to drag and drop in our text field, make it full screen or enough to be visible. Say enter name here, and instead of making a button, I'm going to skip the button this time and use label. The reason I'm skipping the button is, I'll just show you in a second. Say welcome. The reason I'm skipping the button is when I type something here, you open this, open the keyboard. You can open the keyboard again by going to keyboard and using toggle software keyboard, or use command K. When I type something here and press return, that's when I want the function to work, not anytime else. So how do we do that? The thing is, this text field or this keyboard is part of text field, and text field is a different class which is created by Apple. So if you look at the text field, or if I go ahead and create an outlet here, say my text field, create one for this guy, call it my label. Okay, so I have both of them available here. Now if you look at text field, it's a class that is created by Apple, and this is view controller, is a class that we created. Now I want them to communicate with each other, which means that whatever happens in this keyboard needs to come back to my class, which is view controller, and tell him to do something. So they are trying to communicate with each other. So when I do all these things, it's pretty much related to text field. But when I click on return, my view controller doesn't know what I'm clicking on. So how does the view controller know? So there are some protocols that are defined by text field, which we can find by saying one easier way of doing it is we need to first say who the delegate of who is going to implement all this function that this guy has defined, all the protocols that, or protocols, rules, delegates, whatever you call it, this guy defines them, who's going to implement it. It's this view controller. So that means I can go here and I can say my text field dot delegate equal to self. So this view controller is going to implement it. As soon as I type that, might give me a warning or an error saying that this text field doesn't look like it's following any delegates. The reason it's doing it is because I need to push this here. I'm going to say this can follow UI text field delegate. So by doing this, I'm kind of saying that okay, this guy can follow the rules that are set by the text field, and those are defined right here. We just stop the application and go here. I can say jump to definition. It will take me to this particular. Sometimes what happens is it doesn't display it in colored format, so I can open Xcode again, file, can go to my application, click here, jump to definition, and here you go, UI text field delegate protocol, and these are the different protocol functions that are available. They are just defined, they are not implemented. So what I have to do is I'll see which one do I like. Text field should begin editing. I don't want anything to do with begin editing, did begin editing, should end editing, text field did end editing. I don't care about all these. The ones that I'm interested is text field should return. If you look at this, it says optional, so I can implement it. If I don't implement it, it will still work, but I want this so I can tell my application that there is this return button pressed and I want to do something with it. So when I press this return button is pressed and something has to happen. So that's when I implement this particular function. So I copy this, I go to my view controller, and right here I can say that I want to implement it. It looks like my UI label is broken. If you see this here, that means something's wrong with UI label. I can go back here and make sure that the connection is there. Now it shows the connection is there, so that's good. Not sure why it was showing me that the connection is broken. Anyway, so let's go back and say return yes or true. So what it's saying, a text field should return. So it's asking me, should I return it? I say yes, you should return it because returning bool. What else do I want to do? What I want to do is I want to set my label text to be whatever the text field contains. I can use this text field, my text field, or it also returns me the text field. So I can use that to, depending on whichever you want, you can use that. I like to use the one that is returned by the function. It's much more easier to use. If you have multiple text fields and they're all implementing and this class implements the delegate, you can, this might be a better option. So I have this. I can also make it welcome, something like this, and now I have my label being displayed over there. So string interpolation, so I'm just going to make sure I have some text, or if you remember this, we did this, you can do a flat, you can do this, but I'm very sure there is some text or there is empty text, so welcome will be displayed anyway. So I have this available now. Now when I run this, let's go back to a simulator, go and type something here, return, and if you see, it takes the value and displays it here. If I want to get rid of my keyboard, text field dot resign first responder. Let's try that. Installs application, have my, then I'm going to press return, welcome Vivian, keyboard goes away, the focus goes away from the text field. So this is how you can implement a simple delegate. I'm going to go over one more just to explain it better. So in my storyboard, I'm going to add one more guy who has a couple of more things than just delegate. So I'm going to look for a picker, use the basic picker view, not the one with date. Use this, and next I'm going to make sure I connect this, take this, and let's make sure it's selecting the right one, and link this one. I'm going to call it my picker view. So I have my picker view. Now picker view, if I run this application without doing anything, what will happen is it will display my picker view, but you will not see any data being displayed on it. So other than action, you can use protocols also to pass value from the view controller to the picker view, and that thing is something called as data source, or in this case UI picker view data source, and I have UI picker view delegate. So two different items, and I'm going to use the same thing. I'm going to say my picker view dot delegate equal to self, and my picker view dot data source equal to self. So both of them defined. Can go back to my definition of this to make sure the application is not running. Okay, go back. Now if you see here, I have a warning or error here. Do you want to add protocol stubs? The reason it's asking me to do this is because if you look at UI picker view data source, it has two functions here which need to be implemented. They don't have the optional keyboard in front of them. So what I'm going to do is I'm going to say, instead of me copying from there, I'm going to say yes, please use it. And if you see it adds it here, I'm going to remove them and move them to the bottom. Get rid of that. First one is number of components. What are number of components? Let me just give 2 just to show you. Second one is number of rows in components. I'm going to say return 4 just to see how it works. So if you, number of components are the vertical elements. So if you see here, these are components. So there are 2 components that I have, and each component has 4 rows. If you see 4 question marks, the reason I don't see any text over there is because I didn't set any title for each one of them. I can also say here if component equal to 0, if it's first one, then return 1 or 2, and now when I run it, I'll have 2 in the first one and 4 in the second one. So 2 in the first one, 4 in the second one. I can increase this number of components to as many as I want, but make sure that you don't actually overdo it. If you have more items, then you probably want to use different things. So if you see here, I have all these different elements. Now what I want to do is let's put some text here. So the reason it's not displaying text is it's not part of our UI picker view data source. So I'm going to go here, jump to definition of my picker view delegate. You'll see here first one is width for component. So you can specify width for each and every component over here, how much width you want. You have row height, which you want for that. Next one is title for row. So what is the title? This is the one that we want. Then there's attributed title. There is view. You can give a particular UI view for that. And then when it's selected, you want to do something. So I'm going to pick these 2 for now. This one. So this will give titles. And the next one that I want to pick is this one. When it's selected, what should we do? So I'm going to use that, these 2 functions. So in this one, first one, I'm going to return. So whenever a particular, what is the title that you want to give? So I'm going to just give the row number for them. So I'm going to say, since it needs a string, I'm going to say R, since I have 5 of them, let's reduce this to 3 row, and I'm going to say row number, something like that. And since the row starts from 0, I can always increment 1. I can say row plus 1. So this way, when I run this, we'll say R1, R2, R1, R2, R3. And which component do they belong to? If I want to specify that, I can always give component plus 1. And this way, I have the component number and then row number. So first one will have all 1, 1, 2R, 3R, and row number. Now when I select something, I want to change the, let's use the label for that. Since we already have label available, I'm going to say you selected component. Which component? I have the component number over there, component plus 1. Since it starts from 0, row plus 1. So this will display that in my text field. So that's how delegates and delegates and data sources are used. So it kind of helps you do a bunch of different things, especially communication between two different classes. And we'll look at how to create your custom delegates, or how do you create a view and inside that you have your own delegates defined, so two classes can communicate with each other. These are some of the things that are already provided: the delegates for text field, delegates for picker view. Every time you add an element, you can look at what all different delegates are available, so you can do more with those particular elements. But now let's move on to how to create our own delegates or protocols for our application. Protocols. Now that we have seen delegates, which are type of protocols, let's see how to create your custom protocols. So custom protocols are nothing but a way for two different classes to communicate with each other. So if we have already view controller and we create our own custom class, then if we want a way to for them to communicate with each other, we can use protocols. So what the second custom class does is it will set a bunch of rules or functions it will write, which the person who's using it will implement. What do I mean? Let's start with the project. So I started with the blank project. I have a single view application here. I run this and I will see my simulator open up. Make sure I have space for both of them and open my simulator on the side and have this available on both sides. So to this particular view I want to add two different views. So I can go here to my view did load, can create a custom view. Let's create a custom view class. I can say want UI view, we'll call it custom view, create that class. So I have a custom view object here. It says that draw, if you only want to draw everything from scratch, use that, or else don't use it. I need to add an initializer method and have to call the super init. This is required, and I think I need one more which is this required method, which I'll add there, and then I can call the super initializer for the coder and have that available. So I have both these functions ready. Here is where I'm going to do most of my work. So what I'm going to do is, first let's go here and inside this view did load, I'm going to create an object. I'm going to call it let's say let the view equal to custom view, and use the frame method and give it a rect of started at 50, 100, 100, 100. Let's make it a square. Can also give a background color to this, dot background color equal to dot red. Next I'm gonna say the view dot or actually add it to the view, add sub view the view. So I can do one of them. Select one more of these, increase this to 200, so it's not at the same place. And I'm going to call it blue view because I'm going to change the background color of this guy to blue. So I have this. Let me run this and let's see if it shows up. There should be two different views, one red and one blue next to each other. What I want to do is when I tap on these, I want to kind of display something. So I can do that. I can go to the custom view here. I can add something called as a tap gesture, which is let's touch gesture equal to UI tap gesture. Will ask me who the target is. I'm going to say self, this particular class, and selector is a function. I'm going to say print this something, and when I have that, next thing is touch gesture dot, let's say how many taps you can have, something like how many taps required. So that's number of taps required. I'm not sure why is it not auto completing it, maybe because my function is not available. I can always create the function here, function print this. Again, it's Objective C style, so it will ask me to add Objective C, but before that just add this tab gesture, add gesture, and the gesture that I want to add is my touch gesture. So as soon as I do this, it will say fix this, which is what we have seen before. We have to add @Objective C here, and that's it, and I have my tap gesture available. The only problem now that print this function is there. One more thing just from the previous thing is user interaction enabled. I'm going to set that to true, so that means user can interact with that item. Run this. I will not know if anything happened, so just for that I'm gonna say I was tapped. See, run this application, it will add those two items, and when I click on this, so now the problem here is when I tap on this particular guy, only this guy, this class knows. When I do about this, only this guy knows. So if I want the view controller to know, what I'll have to do is I have to create a protocol for that. So this guy is going to set the protocol. He's going to say I want to create a protocol. I'm going to follow like the same standards as Apple does, and I'm going to say function. I'm going to create a function, send me color, and this will send color to our parent, who's the view controller. So whenever this is tapped here, I'm going to call this function, and this function which is implemented in view controller will be called. I can add one more function and say what's your job, something like that, or I can say tap occurred. Okay, I have these two functions available. Now to make sure that a delegate can be assigned, I'm gonna say custom delegate, and I'm gonna give it its type custom view delegate. I'm gonna make it optional, so that's this custom view delegate. So whoever is implementing it, he can say okay, the view, or in this case the view dot has a custom delegate, and who's the delegate for this is this particular class. That's what we did in the previous one, where everything was available for us from Apple, but now we have to implement it. So I'm gonna give it delegate. So I have the items added. It's gonna say that I'll have to insert a kind of, the reason this cannot assign value of the type, the reason it's asking to do this, if I even do this, it will the reason is because UI view controller doesn't have it doesn't follow the rules. So I can always say this follows the custom view delegate, that way these errors will go away. Okay, now that is there. The next thing is it's saying that you're not implementing the functions, so add the protocol stubs. So I'm going to add those two functions there. So if you see, what happens is I've added these views here. When these views have these function, so this function, this view will actually call these functions. Where should I call them? I'll call them here. I'm going to say whoever the custom delegate is, I want to send you color, and that color is self.background color. Same thing, I can use the other function to tap occurred, so even the parent knows that tap occurred. Even with this I can send it, just but I wanted to create an extra function. So I have this available. It's gonna ask me to fix this with, it doesn't know if the background color is available or not, so that's why it's asking me to do this. Tap occurred is a function, so there you go. So I have both of them added from the custom view side. Let's go to the view controller and make sure that first I'm going to print here and say tapped in view controller. Next, here since I've got the color, I can do something with the color, but for now let's look at one function. The second function is implemented, but we are not doing anything in that function yet. When I click on here, so if you see, I was tapped in view controller. So both of them know, but how do I know it's coming from this right guy? So for that I have this send me color function. I can say self.view.background color equal to color. So what I'm doing here is I'm saying whatever color is tapped, the entire view's background color should change to that. So now when I run the application, install it, when I click on this, the background color is red. Click on this, background color is blue. So I know which one is tapped and which one is not. So that's how you can kind of communicate between two classes and build your own custom delegates or protocols, whatever you want to call it. It means the same thing. It's kind of making sure someone else is doing your work, or you're delegating your work to someone else, or You can also call it protocol, where two different classes are communicating with each other through a protocol or a set of rules. Notification center. So we saw how protocols works, what are delegates. Protocols, what it does is usually is one-to-one communication. If you saw, there was one person who was actually adding someone else into its view, and then they were communicating between each other. It's more like a phone conversation. When you call someone, you talk to the person and the person talks back to you, or it's more like a delegation where you delegate it to one particular person. Whereas in notification center, it's more like a broadcaster, where one person is going to broadcast a message, and whoever is listening or whoever is tuned in to that particular I'd call it medium, all of them will receive the notification, and they will do whatever they have to do or whatever they implemented inside the code. So that's how notification center works. Again, just a difference between protocols and notification center is protocol is one-to-one communication, whereas notification center is more like one-to-many communication. Let's go back, and I have already created an application where I don't want to spend too much time in. So I have my view controller where I've added three custom views, just like the protocols that we created before. Custom view, I call it red view, green view, and blue view. I've given them the frame, background color, and added them to the view. Now inside my custom view, I have done nothing but initialize the basic initializer, required initializer. I have the frame initializer where I've just added the gesture, and when I tap on it, it should say inside the view. So that's what happens. So now to add notification center, what we have to do is who is going to listen to the notification. Let's say if the notification comes from inside the views, and the guy who's listening to the notification is the view controller. So in here, I'm going to say notification center dot default. So I'm saying the default notification center. I want to add an observer, and who is the observer? The current class self. What is the function that it's going to implement? Let's say same as add target that we added for buttons, and the name of the function is, let's say, the notification, and it also passes the notification that it received. Okay, so that's one thing. And then next one is name. The name that I want to give is, let's say, ns notification dot name. So this is how I can set a name, raw value, and the name of the notification, in this case I'll call it my notification, and object, I'm going to say nothing to pass. So that's it. So I have my observer added. The only thing that is missing is my function. So I'm going to go here and say I want to add this Objective-C func, the name of the notification, and whatever is passed to it is of the type ns notification. So this guy here, whenever this notification, it hears about the notification that it occurred, it will take that and pass it to here, and also pass the notification object that it received. So this guy can do whatever it has to do. So that's my function. Here I'm gonna say, just for now, say print received notification, and if you want more here, I can say slash whatever notification I received, what's its name. You already know we are subscribed to my notification, so it should be that. Now how do I post the notification? So inside my custom view, what I'm going to do is I'm going to say, okay, only when it's tapped, not when it's created. If I do this, it will be sent as soon as it's created. So as notification center dot default dot post notification, and this is how I post notification. I'm going to use this one because I'm also going to pass the name of the notification. I'll use the same thing that I used before, notification dot name, and the name with the raw value of string, which is my notification. Object self. It's always better to kind of take this and make it constant and then use it everywhere instead of doing this, so you don't have to kind of misspell it, or if you do a typo, it will not be listening to it. So let's run this application. and now here when I click hit, if you see received notification, my notification, so it displays me the notification, the name of the notification, everything. So that's good. Now what if I want to do something? So in here in my view controller, let's do the same thing that we did before. Let's get the view from the notification, because if you see what's happening here is I am passing the entire object with the notification. So that means I can get the entire object. So I can say notification dot object as custom view. So I got the entire object here. Once I have that, I can say self dot view dot background color equal to the view, whatever I received, whatever its background color is. So I'm doing same thing that we did in the previous video. Run this. My application installed, opens up, and now when I click on red, notification, along with that the color, the view, and that's how this thing works, green and blue. What if I want to send a notification to everyone? So let's say I want to send the same notification to all the different objects that are available, and these guys are also listening to it. So all I have to do is I can say that even this guy, so whoever is sending, that guy can himself can also be listened to notification. So I'm going to say add notification, and I've added this particular thing. Same code for this guy. You can do something different in there if you want, but what I'm going to do is I'm going to say that notification received inside, just to show there's something different, and it doesn't have a view because itself is a view. So now it will work only once, because once the notification happens, everybody will have the same color, right, unlike before. So if I click on red, everyone is red, and you see that there's 3 times the notification was received inside, because there are 3 different objects. So this, when I click on this guy will send a notification. He himself will hear, even this guy, and the main view controller. So that's how notifications work. So it's helpful when you have to send a notification to someone. The object exists, doesn't exist, your job is done. You're sending the notification. Whoever wants to listen to it will listen and update it automatically. It's more like, when you check your email, and if an email comes up, the notification is sent to entire view, and you'll see, like in your Gmail, on the left side the count increments to 1, on the right side you see the email show up, on the top it says 100 email and is increased by 1. So that's why notification can be very helpful. Table views. One of the most important views that we have is a table view, not because it sounds important, because it's used in every single application that we build, and all the application that you'll use, you'll probably see it, including the phone book, diary app. All these apps have the table or a list of items where you display, and every time you need one, you want to use one. So let's see how to use table views. And the reason I have kept it a little bit behind from all the other views is because I wanted to go over delegates, data sources, protocols before I do table views. So now we can understand table views much better. Let's go ahead, and we've created table views before, but this is simple application with a single view. And if I run this application, we run this in 8 because I have the emulator working here. iPhone 8, and I have it running right here, and it runs the application, and I have nothing inside it, so I've not added anything yet. So how do I add a table view? So I can go here to my storyboard, look for a table view. I'm going to show the importance of table view controller, but for now let's add a table view. This is what we did before too, but we created more of a static table. If you remember, when we selected last time, we created static. This time we'll keep dynamic and let the code update the table that we want. So we've created a table view. Next, I'm going to go and create an outlet for it. I'm going to make sure this is selected, or I can also select this and then create a table view here. I'm going to call it my table view. Okay, so I have my table view available. Now when I run this application, I should see a table view inside my application, inside my device. So I have my table view displayed here. Now in here I can go ahead and play with this table view, or I can go to my code and write some code for it. So let's do the code version this time. So for the table view, as soon as it loads, I'm going to say my table view dot delegate equal to self, my table view dot data source equal to self, so I can provide data. This is similar to what we did with picker. Go up here, say UI table view data source, UI table view delegate. Now it has a lot of functions that are available. If you go to the protocol reference, you'll probably see a lot of different functions that are available in a table view, or I can just go into directly to a definition and see all the different functions available. There are a couple of them inside the data source which are required, and that's why you'll see that errors pop up here. You can just fix this by adding these two functions, and I can kind of get rid of this and this and then use this. So first one is number of rows. How many rows do you want? Even though it shows so many rows here, it's just a template. It doesn't have any rows in here. They're all blanks. You can kind of figure out by clicking on them. If nothing happens, that means it's just a placeholder. I can just say return 10. And how do you want to display the cell? So I can say that since it requires a UI table view cell, I'm going to say let cell equal to UI table view cell, and then I can specify a style. This is same as what we did when we created cell using this particular thing, where we created a cell and we specified that this cell is custom or basic, which style it is. So I'm going to get rid of that right now, go back and say my style is, let's say, default. Reuse identifier, I'm going to go over this reuse identifier in a second, but first let's look at this. Once I have this, I'm going to return this cell back. Just to see if it actually works, I'm going to also give a background color of red, so it's clearly visible. So when I run this, now my table should have 10 rows with this particular cell which are red in color, and there you go. So if you see, I can click on this, even though you can see some rows at the bottom, but you can't do anything with them. They're just placeholders. Now there are a lot of different functions that are available. There's also something called as number of sections in table view. Again, this one is for number of sections, which is a separate header. So now we'll have 5 into 10, which is 50 rows available in here. So if you see, all these rows are available. If I want to give a header to the section, I can use view for header in or title for header in section. How do I know all this? Because I've used it quite a lot. They're all available inside the data source and the delegate of the table view, so you can go through them and look at them. And for this, I'm going to say return header. Now you'll clearly see the difference between the sections and the rows, or where a particular section ends. So if you see first one, second one, third one, fourth one, fifth one, I can give it a better naming convention by saying section +1, because it starts from 0. And now we'll see header 1, header 2, header 3, header 4 and 5. So 1, 2, 3, 4, 5. So we have these headers. So I'm going to get rid of this. We don't need different sections right now. Similarly, there's a bunch of different things that you can look at inside that particular. So let's go to the data source again, and you'll see a lot of different functions available here that will display cell, will display, did display, height for row. Height for row is something that we'll be using in a little while, but there's a lot of different things that you can kind of play with. So let's go back and run our, so this is what application we have. Now the problem is, how many times is this cell created? You'll say 10, right? Let's see. See, we don't know yet. So what I'm going to do is I'm going to create a variable named as count and start its value at 0 and increment this value. I'm going to say count +1, so whatever the previous value is, and I'm going to print the value of count. Run this. Now I have this. How many times does the count get created? If you see, 10 times, right? Let's go back. What's happening? incrementing. So what's happening is it's going to create it 10 times, and whenever the view gets out of the cell gets out of the view, what it does is it will remove them and redraw them when they come back. So that means if I have, let's say, 1,000 cells, it will create these cells not only just 1,000 times, but depending on how many times I go up and down. So that's how this cell technique works. And so what it will do is it will take a lot of memory. Think about it, drawing these cells again and again depending on how many times user drags up and down. So now I've not even gone to the 1,000 cell and I'm already very close to 1,000 count. If you see the scroll bar, it's right here. So what we'll do is, instead of doing it this way, let me get rid of, actually let's keep that. What I'm gonna do is let's remove the count. We don't want to see that. I am going to create a cell in a different way, in a reuse identifier way, which means that if whenever this view moves above and is removed, I'm going to reuse them at the bottom and use it here. So I'm going to recycle the views. So that's a much better way of doing it. So to do that, what I'm going to do is I'm going to create my cell by asking the table view, do you have any cells that I can reuse? That's what I'm going to ask. And what is the identifier? So identifier is, if you create a cell, you can give it a name. So I'm going to say my cell, and index path. Index path is nothing but combination of section and row. So which section does it belong to and which row does it belong to? So this one is saying my cell, but I don't have a cell that it knows of how to create it. So I'm going to go back to my storyboarding, pick up a cell, drop it here and name it my cell. Give it a name. Instead of custom, I'm gonna use, say, subtitle one, so it has displays looks like this. Run this application. Now what will happen is it will take that cell and draw it whenever it's not available, and then whenever it's available, so the first one that goes up will be reused at the bottom, and when I go the other direction, the bottom one will be reused above. So at a time there'll be only these many number of cells. And if I increase the height, if I say height for row at index path and increase the height to, let's say, 150, it will draw, let's say, it will show up a few number of cells, 1 2 3 4 and 5. So I still see the fifth one and sixth one, so it will only draw 6 cells at a time and not more. So that's how this reuse identifier works, and this is how the table works. Now you can kind of, since you added the cell here, you can do whatever you want. If you want the accessory to be detailed disclosure, you can add that, and that will be displayed on the right side. So you can customize your cell however you want based on whatever things are available. But what if you want to make a very customized cell, like, add some images? It actually comes up with the image too. You can add an image. But what if you want to add like a slider, a switch, bunch of different things to your cell? How do you do it? So for that, we'll look at custom cells in the next section. Now that we know how table views work, let's look at custom table view cells. So we created some cells, but those were the ones that were given by Apple or pre-created for us. So right now, let's go back, and inside my storyboard, I have a view controller. What I'm going to do is, instead of adding table view controller this time, I'm going to just get rid of this view controller and add a table view controller. What table view controller is nothing but a view controller which has table view inside it. And if I create, let me just create a new class called as UI table view controller and call it table view controller. Save it, move it inside here. So my table view controller. Now I have to make sure that this one is that class and not UI table view controller. So I have that. Also make sure that this one is the first view controller that gets opened. So that should be right here, is the initial view controller. So we have arrow here. Just run it and see if it works fine. Run it in iPhone 8 instead of 8 Plus, because have the application, have the emulator already running for that. So it works fine. So I have this, and where is my table view? I don't see my table view right now. Let's open it one more time. So there you go, there it is. And next, what I'm going to do is I'm going to say that these cells that I'm using are custom, they're of the name my cell, and then I can use this table view control. Let's look at inside this. So if you see, it has everything that I need. Table view, number of sections, it has a number of rows in section, number of sections. I'm going to say I have one section. If I remove this, it will by default give me one. Add 10 of these, then uncomment these, and if you see, it still uses that, but my reuse identifier is my cell, is what I've set here just to cross check. Can go here and check out this cell. It's called my cell. Also it takes the name here. Go back, my cell. Perfect. Now instead of writing all the code in this, I'm going to create a separate class. I'm going to say new file, and I want a UI table view, not a controller. I want a cell. Name it table view cell. Create, and I have my table view cell also added here. So here I can select this table view cell, go back to the class and say this is going to come from here, table view cell. Get rid of these functions. Okay, now it's gonna, let's use the init method that is there, not this one. Have another init method which is the required decoder init method. I'm going to say super.init a decoder. So there you go. This is what will be called by that particular application. I can always add a print here just to see if it works. I am here. So okay, so I've done this. I've created my, move this here, table view controller, 10 items. I don't have anything inside the cell. It's empty cell right now, and this is where it's coming from. So let's run this application, and now it's installing, and there you go, it opens the application and we have the cell here, and I'm here is called. So that's perfect. So that means it's working. Next thing, to make it customized, let's start drawing here. So I can add a label here. I can increase the size of this label. Let's say make it a little bit big. Can add one more label below it, a smaller label. I can add whatever I want. I can add a switch in there if I want. I can add a slider inside that if I want. So this is a custom cell, so which means I can add whatever I want. Now when I run this, will this display my table view with 10 elements? Let's see. So if you see, it's cut off. The reason is because I have to add the row height depending on the height that I've selected. If I go to this guy and see it's 184, so I can take that and say that height for row at index path, return 184, and run this. I think I got the wrong method. Fix it. Override has to be there. So yeah, that was missing. Now when I run it, it will have my 10 cells with all these items in there. You know, it's being reused because if you see this, I just moved one and this guy got moved. If I change this to the end, you'll see this got reused there. So this is how you know you have reuse. So that's why you'll have to make sure that you update these values every single time, and everyone has a unique value. If they have no value, it will take the one from the reused element. So that's our custom cells. We created custom cells here. You can use this, and we'll be using it quite a lot for when we make our projects. Collection views. So we have created table views. Collection view is something similar like table views, just that they're in a grid format like your photo gallery. So it can be used to add bunch of different things in a grid format instead of a list format. Let's start looking at collection views. It has everything similar, so I'm just gonna show the basics of it. For example, I have an app delegate here. This is an empty project that I've created, and I'm just gonna search for collection views. So it has similar kind of format where you have your collection view, you have your collection view cells, you have a collection view controller too, just like table view. So you can follow along, but I'm just going to give you a small demonstration of how collection views work. So I'm going to add this collection view cell here and make sure it takes over the entire screen. Now if I run this application just like this, nothing will happen. It will just show me an empty collection view application until it launches. I'm just going to go in and make sure I have a outlet here for collection view. Call it my collection view. Let's look at it, it's still launching, so I'm gonna still go ahead and do a little bit more on the collection view. So I've added this. It has something similar like delegates and data source, so I can go in here my code. So if you see, there's nothing you can see right now, so I'm gonna go inside here and my collection view dot can say, let's add delegate equal to self, my collection view dot data source equal to self. Now it's gonna not work because I have to say UI collection view delegate UI collection view data source, and now these errors should go away. Let's close this and make sure I run it on phone 8. Now once I do this, of course there's some methods that are missing which probably our collection view data source might have it, so I can jump to the definition of this, and if you see, there are a couple of them, like number of items in sections. So if you see, even the names are similar to table view. So if you're familiar with table view, collection view will not be that difficult. Let me run this one more time. It will not work because I have this error here. Let me run this first. Number of items in section, so I say 110 items. Cell for item at index, so it's asking what is the cell, similar to the table cell that we have, but in this case it needs, okay, how to say, return 10. Here I'm going to create a, let's say, let's call it cell itself, and it has something similar like table view where it dequeues, so I can just say dequeue, same names, dequeue with dequeue reusable cell with identifier. I can give an identifier my cell. For index path, I'm going to give the index path that is passed, and I am going to return this cell. Now I'm not going to go into too much detail of collection view. I'm just going to go here, take this cell that we have here, give it a particular name which is my cell, and give it a background color so we can actually see. Pick probably one of the existing ones. Run this application now. Let's see if we are missing anything. So installs, and we have the 10 cells displayed here. Similarly, we can have multiple sections. I can always say number of sections in collection view, and I can return, let's say, 5, and now when I run it, I'll have 5 into 10, so 5 sections, each with 10 cells, and I have those. The spacing there, the thing is, the first section is merged with the second one. What I can do is I can go to the cell, go to the properties of the cell right here, make sure I have the right thing prepared, and here inside this, for the view, I can give something called as the insets. So I can set top 5 5 5 all way, so it has 5 pixel margin all around it, and now I have proper distinction between first, second, third, fourth, fifth. So this is how we can do it. Next thing that I can do is I can also always add things inside it. I can search for a label and then add a label inside the center. Run this. I can connect this to create a custom cell just like table. I'm not going to add all these things, extra things. Now if you see, since I made a little bigger, the spacing is a little bit more. But you can keep on doing these things for cells, and you can create your own collection view cell. So that's how collection view cells. I'm not going to go into too much detail. Feel free to explore, and if you have any questions, let me know.